Welcome to the Azure DevOps Full Course. If you're looking to take your career to the next level in cloud computing and DevOps, this course is exactly what you need. Whether you're just starting out or want to design your understanding, we have got you covered. You will learn all about Azure, how it works, and why it's such a powerful tool in the cloud world. But we won't stop there. We'll dive into DevOps practices, how they integrate with Azure, and how you can use them to build, test, and deploy faster, smarter, and more efficiently. Think of this course as your roadmap to mastering the essential from setting up Azure Virtual Networks to understanding the power of Kubernetes and Docker in DevOps workflow. Plus, we'll also help you get interview ready with key Azure and DevOps questions so you can nail your next job opportunity. By the end, you will be equipped with real-world skills to confidently tackling any DevOps challenge. Let's get started and make your cloud development your new superpower. If you're interested in becoming a cloud expert, Simplilearn's Cloud Architect Master Program is the perfect choice for you. This comprehensive program helps you master top platforms like AWS, Microsoft Azure, and Google Cloud, equipping you with in-demand skills to design and deploy scalable cloud solutions. You'll gain access to official AWS authored learning content, hands-on projects, and even the Microsoft exam voucher for an Azure certification. Over 4 months, you will dive into 40 plus industry relevant skills, including cloud architecture principles, AI, DevOps, and more with live interactive classes led by experts. Cloud computing is booming, with 98% of companies already adopting it. You can find the course link in the description box and in the pinned comments.
Now, let's start with why you should be interested in cloud computing. Now, let's say you have an idea for a revolutionary application. An idea that ticks both the boxes when it comes to good applications. One, it has great user experience. And two, it'll be highly profitable. Now for it to be successful, you'll have to release it on the internet. People need to use it, they need to spread the word, and then it'll become truly famous. However, for that, you're going to need servers, storage, developers, a dedicated network, and application security to ensure your application works the way it does. Now these are a lot of components. And that's where the problem lies. There are two major disadvantages to this approach. The initial setup is very expensive and risky, which means this requires a huge amount of capital upfront to ensure that it works properly. And the downside is, if your application does not become famous or it doesn't return as much as you expect it to, you're probably not going to get the money back, which means it provides a huge amount of risk. And then, on the flip side, if it does become famous, your number of users have increased, which means that you'll have to buy more servers and storage systems to keep up with your demand. And this problem can be solved with the help of cloud computing. Now that you know why you should be interested in cloud computing, let's go into the details of what exactly is cloud computing. Now, cloud computing is basically a platform that gives you access to a number of computing resources. And this is possible with the help of the internet. Now, as a user, all you need to do is go to a cloud service provider through your laptop or your computer, through the internet, of course, connect to that cloud service provider, and then there you go. You have access to computing resources. Now, computing resources may include, serverless computing, virtual machines, storage, and so much more. Now, let's dig a little deeper. Now, basically, these cloud service providers actually have massive data centers. Now, in these data centers, what you have are hundreds of servers. Also included are storage systems and mainly several organizations' critical components. So these are very secure, safe locations where a large amount of data is stored, hence the name data centers. Now, it is to these data centers that users actually connect to collect their data or use it. So actually, users can access any service based on their requirement. Now, like I told you, there's a number of services the user can use. For example, now if you want a notification every time someone sends you a message, or perhaps once you get an email, you need a copy of it created. Now, for all of this, there are services. And most importantly, almost every cloud service provider has this option where users only pay for the service that they use. So there's no charge upfront where they tell you that you need to pay X amount of money so that you can use our services. You're only paying for the amount of time that you're using these services. Now, cloud computing is used for a wide variety of reasons. Firstly, there's machine learning and data analysis. Now, basically, there are services that analyze your data and tell you how you can work with this data better. Then there's data storage and backup, streaming media content. For example, did you know that the shows that you watch on Netflix, Actually, all of them are in the cloud. So you're connected to the internet and you browse through Netflix and you get access to the videos. These are possible with the help of cloud service providers. There's creating and testing applications, automating software delivery, which is a component in DevOps, and hosting blogs and applications. So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched in February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have ExpressRoute. Now with this, you can actually connect your on-premise network onto the Microsoft cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have virtual network. Now with virtual network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development, it could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices, for example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines, where these services are able to provide you a large amount of storage where data can be stored.
Let me take the pleasure of welcoming you to this Azure tutorial. I'm Sam, an Azure Cloud Architect working for Simplilearn. And I'm more than glad to walk you through this session where we're going to talk about Azure in great length and breadth. And if you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. And without any further delay, let's get started. Everybody likes stories, right? So let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers. And what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud. with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use, and this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in an organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hour, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. If we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right. Instead of in traditional data center, let's say, customers will have to, or their request will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it, and it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one, and also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system, IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now, just know that there are a lot of services available in Azure Compute Service that we can get benefited from. We can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay per minute billing basis. All right. And at no point, because of the pay per minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent, regardless of whether you choose Windows or Linux. It's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale, parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators, so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application, instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances, or the number of VM instances in a scale set, can increase or decrease in response to the demand, or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon, or after 8 or 9 in the evening. So the demands could actually vary in the environment, and this scale set helps us to take care of the varying demand, or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The skill set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine skill set? Just like I said, this virtual machine skill set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability, or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment, where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now functions are serverless computing. Many times if you heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing, or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless, simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages of code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. Alright, as next thing in container domain, let's talk about container registry. we spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, these geo-replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, these Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It is very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of. So I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure CosmoDB. Now, Azure CosmoDB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure CosmoDB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure CosmoDB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides or Azure promises a comprehensive SLA that no other database can offer. That's the best part about Cosmo DB. So this Cosmo DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmo DB and the SQL database is that Azure Cosmo DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmo DB is it allows users to use key value graph, column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis Cache. Discussion about Azure Database won't be complete without we talking about Redis Cache. Now, Redis Cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis Cache is based on a popular open source caching product, which is Redis, sometimes called as Redis Cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis Cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis Cache, this fast storage is located in memory with Redis Cache instead of being loaded from the actual disk in the database itself. Now, this Redis Cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis Cache. And by using Redis Cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis Cache engine provides. So to summarize, this Redis Cache, when we use Redis Cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis Cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. And not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, permit or deny based on condition. It can also monitor suspicious activity. And not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now, this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. it integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory, it helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service, and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now, this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now, these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment or the appearance of the environment or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. and they are by nature separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them. Instead of letting them spread, Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps, or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling. That's one advantage you get for content delivery network, that's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay as you go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now Azure DNS allows us to host domain name in Azure. And these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure Virtual Network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us a boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure Virtual Network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage, or Store Simple, is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. It has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is an very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid state drives, and data that is used less frequently is stored in HDDs or hard disk drives, and the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. And for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this Data Lake Store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application. So, it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates or which kind of connects or which kind of decouples both the environment. Now we have a queue in between. Both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol, Server Message Block Protocol. Now, this Azure File Shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all these being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally so it's immediately available when needed. So that's some additional feature. I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he again started his discussion, but from a different angle now. So he started to explain what are the capabilities or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve, the certifications, the documentations, the stage-by-stage certification levels. It's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you, or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial. And I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now. Right. So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. Alright, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save, and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simplilearn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simplilearn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simplilearn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simplilearn DB, and then it's going to be SQL Server. That's the data source. The username is Simplilearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. All right, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry. Take the dog for a walk. That's gonna get stored. I can create another entry. Book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app. I strongly believe you enjoyed me walking you through this session.
Hello, this is Matthew from Simplilearn, and today we're going to go through a complete end-to-end journey on what it takes to set up a DevOps team. We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps, and then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called Waterfall, and Waterfall was a very traditional approach to actually building out solutions. And the reason why it's called Waterfall is that you bring out all the individual requirements and individual sections of a project and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing. This is all based on the software development lifecycle model, or SDLC, and it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to be actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into, though, with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system, and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment, and you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback fallback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with Waterfall and Agile, where developers and operations teams aren't working in the same environment, is being removed, and you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is, when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions, and DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen, what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other so that you're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working, and more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now. So let's dig into Git. So let's look at the challenge that Git is able to address. So before Git, and if you had a team of developers that were working on different pieces of code, one of the key problems you have is that there was no collaboration between the team. And the challenge you have is that with version control, it was difficult and often required having to check in to large environments, or you had very quasi version control environments. It was time consuming. Often there were problems that what would happen if the version control server would crash and there wasn't a backup, then you'd have to kind of essentially go back to square zero to see whether or not you actually had to do the work again. So let's look at what Git does to actually solve this. So first of all, one of the things that Git does is it makes team collaboration much easier. The software itself is more effectively documented and more effectively maintained. The actual code that actually gets worked on by each developer in a Git environment is the complete code. So it makes it much easier for backups and for sharing content amongst each developer. So the way in which Git is able to accomplish this is that it is essentially a distributed version control solution. And what that means is that when you have multiple developers, yes, you do have a Git remote hub that you connect and are able to upload and download different branches of the code that you're working on. But essentially, as a developer, when you actually have the code, you actually have all of the code, and you're able to manage it directly from your local PC or your local development machine without having to worry too much about the network or the server actually going down. So some of the key things in which Git is really good at, it is a software management tool. It's designed from the ground up to manage code development. It does track the changes on that code easily and effectively. It makes it easy for you as a developer to track your code. The ability for multiple developers to work together is much easier in comparison to other solutions. And this is really the key success point with Git, is that it allows for non-linear code development. So you can actually have people working on different areas of the code that may be released at different times because of what they're working on. So if we actually break down the architecture of Git, it really falls into 4 key areas of a working directory, a local staging area, a local repository, and a remote repository. So the process you would go through is you would add files to the staging area from your working directory, and this would be usually the git add command. And then from your staging area, when you're ready to actually then commit those files to a local repository, you would use the git commit command. And then from there, you would actually then push your local repository out to the remote repository for a final commit to the remote repository. And this allows then the rest of the team to pull down your latest final changes. So you can be working on your code locally, and you can be using your local staging area, local repository, and when you're ready to commit your work, you can commit it. And then as soon as it's committed, the rest of the team can then pull down the latest changes that you have worked on. And this allows for a complete and holistic checkout and check-in process. And then sometimes you want to be able to go through and then take the checked out code that you're pulling out and merge it with your local code. And the merge process always ensures that you are working on the latest and best version of the code, and everybody on the team is being consistent with the communication of the actual code that's being delivered. Okay, so what we're going to do is we're going to validate that we have Git running on our computer. We're going to then create a directory, add a file to that directory, make some changes to that file, and then use the commit commands to be able to check in the files and validate changes that have been made. So first thing we do is we're going to see if we have Git installed, and to do that you just use the command git version and git -- version, and they'll actually then give you the version number. And now we're going to create a new folder, so mkdir green, and that'll create a new folder, and we'll move our cursor into the green folder by changing the directory. And we can go back into Windows and we can validate that that directory is actually there. So here we go. Let's have a look. We should see it. There's the green folder. If I double click into that, you'll see there's nothing in the folder right now. So what we have to do is we actually have to add the folder as part of a Git project. And so we're going to use our git init, and they'll actually initialize the folder and make it a Git repository. And so let's go ahead and create a file that'll actually go inside of that new initialized folder. And you'll see that there's a .git folder that's been added. So the new text file we're going to create is going to be called class, and it'll actually be class.txt. The extension is hidden by default. In the text file, we're just going to type in the text, welcome to Simplilearn, and save that. Now let's go ahead and check the status of that file in Git. So let's do git status, and you'll see that it says yes, there's a file there, but it hasn't been committed to the repository. That's why it's in red. So what we have to do now is commit the file to the repository, and it won't be able to track any changes that we do to that file. So let's go ahead and commit the file. So we do commit add class.txt, and they'll add that to the repository, and there we are, it's added. And the final step is we want to do is commit it, and let's do git. So it's let's do git commit -m, put in, this will be our first commit, and this is the description, and so it actually shows us committing the file. It's the only item in the folder. So now we can go over to the file that we just created and we can make some changes to it. So let's open up the file. So it says, welcome to Simplilearn. Let's put in some text afterwards that says, this is my demo, and we'll save that, close that. And now if we go back to Git, we can do a compare and contrast between the original file that we committed and the new updates that we've just done. And we can check the difference by using git diff, and what you'll see is the red text was the original text and the green text is now the new text that's been added. And so that shows you how you can actually go and create a new Git repository, go through adding files, committing the files into the repository, and being able to see the different version controls. Let's move on to Maven. So why use Maven? So why use Maven? Well, let's look at some of the things that you would have done in the past if you actually building out the tasks. So let's break down what you would have done before using Maven if you were to create a game of football using Java. You would actually have to go out and for your actual game, you'd have to collect all of the different components needed within the Java environment to make sure that everything would work correctly. And if you made the slightest mistake, you wouldn't get the right output that you needed. The actual process of building and deploying a project really would take quite a lot of time. After Maven allows you to be able to take templates that are stored locally and be able to use those to be able to improve the efficiency of being able to build out your environment by removing dependencies within the application. It makes it a lot easier for you to be able to focus on just writing the code for your game or your solution rather than having to manage the environment within which that solution would be deployed. Now, the focus within Maven is that it is an automation tool and it's used for projects that have a short period of time. So as you're starting on your environment for building out solutions, Maven is great to get started with. And then if you need to have longer term projects, then you can look at other alternative tools on the market. So 4 key areas that you want to focus on and why Maven can help you is that it does allow for efficient parallel builds to be run concurrently. It's really easy to use. You can get up and started with Maven very quickly. You do have fast access to new features and new configurations quickly within your environment, and the build process that will allow you to be able to visualize your code happens very quickly. The actual architecture of Maven is that the execution and commands are managed through what's known as a POM file. The POM file itself is a project object model, and it's an XML file that actually has the details for the project and the configuration for the build environment. POM file itself will then fetch dependencies from the local repository and will apply any plugins that you may have also included within your Maven environment. The goal is that your software is built in a much more controlled manner. So what we're going to do now is we're going to show you how to go through and run your very first project using Maven. The first steps you're going to have to do is make sure that you have the latest JDK installed on your computer. So we're going to go ahead and open up our web browser and get this installed on your computer. So we're going to type in JDK download into our Chrome web browser and go to the Oracle website, which allows us to download the JDK. And because we're running this on Windows, we're going to download the Windows version of the JDK. And once you have that installed, so the next step is to actually then go ahead and download the Maven files. So it's going to take us to the mavenapache.org website, where you can actually go ahead and download the version of Maven that you need for your operating system. We're going to go ahead and download the zip file instead of just an executable file. Now this will give you more control over how you install it onto your Windows PC. After the file has been downloaded, we want to go ahead and extract the entire file so you have the unzipped folder running on your computer. So one of the things that we're going to have to do is go through and set a number of system variables for the JDK and for the path to your Maven files. And to do that, you want to go into your control panel and select the system security and then system settings, and then go into advanced system settings. This will give you access to the edit system variables setting that you're looking for. So we're going to go down to the path variable, and you'll see already that we have pasted in the link to the JDK right there underneath the variable value. If you've installed the JDK, it's likely that it's already installed this path for you correctly. The good news is it's actually fairly easy to install the path to Maven and to the JDK, because all you have to do is copy the path for where the folder is located on your system and just paste it into a variable value under the edit systems variable file system. And that should now get us all of the files, and you can see that we have our extracted folder already on our desktop there. And the system path is now set to where the Maven folder is located. So we also have to go into system protection and set the system path to your Maven folder. Now we have to go ahead and do a user variable that also links to the path of the Maven files. So what we're doing right now is we're just validating that all the files have been extracted correctly. They have, which is good. We can now go ahead and link to these Maven folder. All right, so now what we're going to do is we're going to move over to command prompt. And this is where we're going to do most of our work from here on out. First command we're going to do is mv. So we're going to go ahead and create a new user variable, and we're going to type in, we're going to call this one m2 dash, and then we'll put in the path to the Apache Maven folder. You should be able to use m2-home for your project, but if it's not, you can always use the variable name maven-home, and that will do exactly the same as m2. We're going to do both here just so we have a backup. So we're going to open up command prompt and we're going to see if Maven is installed. We do that by writing mvn-version. And here we are, yes. So now we're going to go ahead and create our first Maven project. And the first part of creating the Maven project is actually the directory in which we will store the files that will be used to create for our project. So we're just going to go ahead into the folder and we're going to create a new directory, and we're going to call this one, and we're going to call it Simplilearn. And we can just copy the path for that. So I'm going to write the correct path for us. So we're going to change directory, cd, and copy the file location over. All right, we have now moved ourselves over to the Simplilearn folder, and we'll be able to install the POM file, which is what all the instructions from Maven are stored in, into this area. So to do that, we're actually going to use a template that's already been created by Maven, and this is going to be the MVN archetype template. And so you just do MVN archetype :generate, and this will go ahead and create all the files for us. So there can be quite a few files, and they're all being downloaded from the Maven website. So it can take some time, but as you see, we've gone ahead and all the files have downloaded, and we have everything up and running correctly inside of our environment on command line and command prompt. So we'll have some values that we do have to set. The first one is group ID, and we're going to call this one com.mav. And then the next one is going to be artifact ID, and this is going to be mav-project, hit return, and then version is going to be 1.0-snapshot. We'll just put in the same value for this version, which will be 1.0-snapshot. And the package, we're going to call this one com.mav.demo. And then we'll select yes or Y to create the environment, and it will build the environment for us. And what we have now is we have this screen which shows everything is up and running for us. And we have a successful build. So let's go into the Maven folder and just see that we have our Simplilearn folder. Let's open it up and see what's in there. So we double click into that directory. Yep, and there we are, starting to see some of our files. So it's the same project names there as mav-project. And then we have our POM file that's in there, which is fantastic. Under the source folder, we'll actually see the demo, and we have our app under the demo app. We have our test file as well. So in the main folder, we have a file that's called the POM file, and that really is the most important file that you need for your project. You'll now go in, you'll be able to set all your settings inside of that POM file. But that's it. That's what we have done here. Is we've gone through all the setup that allows you to make sure you have the right files running on your computer, the right files to download from the Maven website, how to install all of the files, the settings you need to make on your Windows computer, and then all the settings that need to be done in the command line to be able to run the application. And then from here, you can actually start running Maven. Now let's look at Selenium as we start looking at testing. So before Selenium, if you wanted to run testing, and particularly if you wanted to do sequential testing, it would take up a lot of time. You'd have to run one test, then a second test, and then all of the other tests, and the actual time elapsed would be quite significant. With Selenium, you're actually able to do parallel testing. So instead of looking at the amount of time it would take to actually run a test and run the test sequentially, the length of time to actually run your test is based on the length of the longest running test, of which in this example, the longest running test is 2 minutes. Now, one of the things that you'll notice with Selenium is that its focus is on web applications, and it is an open source tool, and it's really good at regression and functional testing of web applications. If you're doing a mobile application or if you're doing an IoT application, there are other tools you can use on the market as well. But if you are new to DevOps and you're setting up your first DevOps environment, Selenium is a great place to start, and web applications are mature and allow you to be able to test out and validate the concept of continuous testing in your environment. So 4 key takeaways for Selenium. It really is fast. I mean, for fast execution, it's highly accurate, so you can always validate that what you're doing will work correctly, and feedback can be sent straight back to the developer if their code doesn't pass the test. It allows you to script in multiple languages. Again, this is a great way for you to test. The focus is on web applications, but you can test in multiple languages used for web applications, and most importantly, allows for parallel test execution, which speeds up the whole test process significantly. If we're actually to break down the architecture of Selenium, what you'll find is the actual libraries that you can use for Selenium run in C#, Java, Python, JavaScript, PHP. These are the common languages used to build out web applications. The actual web driver itself is an API driver, which is fantastic because it makes it easier for you to integrate Selenium with applications through API. And you can run the solution through different web browsers, the most popular being Firefox, Chrome, and Edge. So to focus, the Selenium WebDriver codes are being used to build out the client libraries that make it to allow you to be able to build solutions across multiple web application environments. The WebDriver application interface is used to integrate with the application to make it easy for testing. The WebDriver service provides an immutable stateless environment that makes it very easy for you to be able to use protocols such as JSON to wire up your test environment. The driver manages the communication between the browsers and the wire protocol that's used for JSON within the web browser itself, and then the actual commands are then run through the web browser for you to be able to get your results. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download, And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download. And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version. And we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. So we're just going to go ahead and open up the Eclipse environment, and it always takes a moment to launch Eclipse. And we're going to go ahead and create a new project, and we're going to call our project XYZ. I think that should be fine, and this is just a test after all. And we're going to go ahead and create a new class file by right-clicking and select New Class. And we're going to go in here and we're going to give the class file a name of Simplilearn. And I don't see the Finish button being selected, so maybe we need to select some other options here. Oh, I think it could be the package name. Yeah, let me go ahead and change the package name, and I'm going to change that to QWE. Yep, and the Finish button has now been highlighted. I can select that. I can go select that and select Finish. And we now have a test page that's up and running, but what we have to do is to validate that Selenium is actually part of the project. So to do that, we're going to go to the source, to the actual source XYZ file, and right-click on it. And we want to validate that all the files are there correctly. And so we're going to see that we have the libraries are there. Yep, there's Selenium. If it's not there, you can select Add External Files and find the Selenium jar file, select Open, and that would load that in there. And then you hit Apply and Close, and that would then apply it to your project. And now we can actually start writing the code part. So we're going to put this code in the public static void section. And the first command is going to be a system.setProperty, and we want to make sure that we're configuring the WebDriver for Chromium correctly. So we're going to do WebDriver .Chrome driver, and then the argument is actually going to be the full network path to the Chromium driver that you have on your PC. So let's see, we have Chromium here. We want to copy that path. And so paste that in. And then after we've pasted in the path, we have to make sure that we also put a link to the actual file that we want to execute, which in this case is chromedriver.exe. And then we want to make sure that the WebDriver is pointing to the new Chrome driver. And you'll notice that there's a couple of red colors on here, which means that we don't have all of the public classes imported correctly. So you can right-click on that and select Import the WebDriver and just select that real quick, and that adds the import correctly at the top of the page. And the same for Chrome driver. And that's just a very quick way when you're working in Eclipse to import additional files. So before we actually start our test, we want to make sure that we've actually cleared out any potential browser cookies that would be within the Chromium driver. So for that, we're actually going to go ahead and we're going to write a script that allows us to remove the cookies. So we want to do driver.manage and then delete all cookies. And the next line we're going to do is to actually have the web page that we're going to connect to open up in full screen mode. And for that to happen, we're going to go and actually use the window property, which is what I was writing before by mistake. And so this will allow us to go full screen. And now we need to pull in a web page. So we're going to get the get command. And what we're going to do is we're actually just going to pull in a web page from Amazon, which I just happen to have here. So I'm just going to go to the Amazon web page. And so I'm just going to copy the URL. Just need to copy HTTPS www.amazon.in or .com, wherever you're located. And so you can see that I've pulled in the Amazon web page, and then line 18 actually allows me to go and connect. So here we are, we have the Amazon web page that I'm pulling in. And then what I also want to do is I want to look for a specific ID in one of the elements. And so I have the driver, which is called find an element. And that allows me to look for any element that would be on the actual page. So here we have the HTML in the console screen, and I can actually then paste out an ID from the element that I want to use. So the find element is just the ID for each element, and most of them have them because they need it for JavaScript and CSS. So let's see, there's quite a few IDs, and we can select any of those. So what we have here is we have 2-tab search text box, and then what that actually does is that finds the ID for the text box used for searching, and then we're going to use the send key command, which allows us to actually pre-fill in the search box, and we're going to use the test of Puma shoes. This is a fixed string, but you could actually put a variable in here if you wanted to pull strings from a database or an XML file. And then the next line on line 19 shows how long we're actually going to run the actual script for the search, which is only 10 seconds. And then once the 10 seconds has elapsed, we'll actually quit the script, which actually closes the web browser and takes us back into our screen here. And let's test that, make sure it's working. And everything's looking good. The web browser opens, which is what we expect. It goes to Amazon, fantastic. It now actually goes to the search screen and should fill in the Puma shoes. There we go, Puma shoes. And waits 10 seconds and it closes. And that's exactly what we were expecting. Now you can actually change the unit of time that you would have for the actual test. So if you wanted to see what was happening, so longer than 10 seconds, you can actually change the actual time or the actual metric. So in this instance, we got it seconds and it's the unit of time, but you could do minutes or hours or microseconds. And you can change the keyword as well, so it could be jigsaws or anything that you wanted to check. But if you're actually building your own application, you want to be able to test your own data against your own application, that's where you put in that specific data. So let's look at the center, the heart of your DevOps environment, and that center is with Jenkins. So before Jenkins, developers would work on their code, and the code would then be checked into a source repository. You would then check for any issues, and then you would then send that code over to the operations team, and there would be a delay for actually delivering software. So the actual challenges developers had is that if they wanted to run any tests, they had to wait until their software was built, and there was a lot of problems in providing feedback, particularly if you had large teams working on software who actually had the error. The actual delivery of software was often delayed because of these key problems. So after Jenkins, what we actually have is the ability to be able to streamline this whole process. The build, test, and deploy happens continuously and are able to then notify developers and the actual specific developer of any errors that are detected, being able to speed up the delivery process much more efficiently. The focus of Jenkins is that it automates a continuous development, testing, and deployment environment. And it's open source. Jenkins is easy to install and configure. It's been around for many years now and it is very mature. There are many plugins that you can use within Jenkins to be able to have the Jenkins product work with your environment. If there isn't a plugin, you can actually you can actually write your own plugins if a plugin doesn't exist. So you can actually continue and extend and invest in the Jenkins ecosystem. And it can be easily distributed across multiple machines. So let's break out the architecture of Jenkins. So Jenkins starts as a remote source code repository, and it then pulls out the code every time there is a commit from into the server master. The server master will then have a slave that will run on either Windows, Linux, or Mac OS to be able to distribute its load across those environments. And after it's actually gone through and run its test, it'll then send out a report. The goal of the report is to communicate back to the team what has passed and what has failed the actual check-in process. Okay, so we're going to go ahead and show you how to install Jenkins on your local PC. So the first thing you want to do is check that you have Java installed. So we're just going to go into our system and see whether or not we have the Java JDK installed. You can do that by going into the System Properties, selecting Advanced, and then Environment Settings. And there we are. We have Java JDK installed. And you want to just double check on the system variables to make sure that you have the Java_home installed correctly as well. And we have that installed. And under Path, also make sure you have a link to the Java JDK as well. So we have everything installed. And what we're going to do is we're going to open up a command window and just do a double check right there. So open up command window and we're just going to check that we have Java installed. So we do Java-version and we have a version number that comes back. If we didn't have Java installed, we wouldn't get a Java version number come back. We'd actually have an error. So everything looks good. So the next thing we want to do is to go to the Jenkins website and download the files. So we're going to go to jenkins.io and that's the official Jenkins website. And if you want to download, you just go to jenkins.io/download, or you can just type into your search bar download Jenkins and that will give you a link straight to the download page. And one of the things that you'll see is that there's lots of different versions for Jenkins, because Jenkins runs on pretty much most operating systems, including Windows, Linux, and Mac OS. But we want to select the Windows version. So we've already gone ahead and downloaded a zip file which contains all of the files that we need for Jenkins. And so that's the zip file and we've expanded it. And what we want to do now is double click the installer file and we'll go ahead and install that. So we've already installed this. So one of the things that we'll get is a message asking if we want to repair. You would actually get a install message because it'd be a fresh install for you. But once you've done that, it has all the files and all the settings correctly installed onto your Windows computer. And we do all of our commands for Jenkins through a web page that's run locally on your PC. And so you're going to type in localhost:8080. And when you do that, they'll actually take you to Jenkins running locally on your PC. And here we have our Jenkins dashboard. And we've already gone in and created some sample jobs, and you can see those listed on the on the right-hand side of the screen. So let's go through some of the things you would want to set up here. So first of all, let's go into the Manage Jenkins screen, and that will actually, so we'll go to the Manage Jenkins tab on the left-hand side to do some standard configuration settings. So we'll go into the configuration systems, and if you want to, if you're like remotely connecting to a remote Jenkins environment, you can actually install a JDK remotely on that machine if you want to. We already have the JDK environment already set up, so yeah, that's good here. So we don't need to do that. But you'll also see as you go through the list of applications that you have: Gradle, Ant, Maven, Docker, Git, and other tools that you would use in a DevOps environment. There are many other tools you can install through plugins as well. Let's have a look at one more setting here with the security. The default security is Jenkins' own user database. That probably is not allowed within your company due to security restrictions. So you can choose LDAP, which allows you to connect with your Active Directory configuration. Again, because there are so many plugins for Jenkins, there are plugins for SAML authentication as well as OAuth. So let's go ahead and start a new build job. And so we'll select a new item, and and we're going to select demo 1 from that to create a new item. And we're going to use just a freestyle project because I just want to demo how you can actually create a build. Select OK. Description, gosh, what could we write here? We can put in Snippy demo. And we're not going to use source code for this one. We're going to do that in the next demo. But what we want to go down to is the job type. And we're going to build. And we can just do add for execute Windows batch command. And so let's just put in a very simple command. And so we're going to type in echo, open quotes, hello world. And then we'll put in the timestamp. So we'll put in date first and then time as part of our output. Close quotes, and we're gonna save that. Also save, and that's our simple project. So what we want to do now is we want to actually go and select the build now command to actually run this project. Hit build now, and it'll take a couple of minutes for it to run. And here we are. This is our project, and we can actually now see the different builds that have happened. And if you look on the build history, you'll see the latest history shows when the build was executed. And if you click on that, you can actually start getting information such as the console output will actually provide information that we were asking for. So for instance, we have, first of all, we can see that the build was successful, and we see the output includes the hello all and date and time. So we're going to go ahead and create one more project where we can actually connect to a GitHub and use the Git command tool to be able to build a real project. So we're going to go ahead and create a new item, and we're going to call this one Jenkins. It's a freestyle project, and our description is demo using Git. So we're actually going to connect to GitHub. So to do that, we're going to go into source code management tab, and we're going to select Git. And so we select that. We can actually now connect to GitHub. So to do that, you go to your GitHub account, and you want to go in and select the clone or download, and you get the URL link from there. So copy that, go back to Jenkins and add that in the repository URL. So you paste that in, and then for credentials, we want to add in our Jenkins credentials. And so just make sure you have those selected correctly, and we've select add, and then we just pull those from the drop down. And let's not change any of the other settings. And then for the build, we're actually going to be building a Java application. So it's a slightly different set of build commands. So we want to type in javac for compile, and then space, and the file name is simply.java, and then you want to put java and space simply on a new line. Save that. Again, this is a really simple application, but it gives you the understanding of what you need to do here. And so we saved it, and let's now go ahead and see if everything's working. We'll do the build now and see what happens. And here is our first build. We select that. We can go to the console output for details, and what we can actually see if we scroll down is that the finished output at the very end says success, which means everything was built correctly. And so that's how you're able to connect Jenkins with a Git repository. And the thing that's great with working with Jenkins is that it connects to so many different systems and really does become the central point of your DevOps toolset. So let's start looking at the operations side of the DevOps environment, and let's focus in on Docker. So before Docker, the problem you had as a developer, if you were working on a virtual machine, the actual virtual machine was your VM, was a very complex piece of software. So first of all, VMs have not been around for very long. We're talking about less than 10 years. And the typical way of having a VM is that it's very heavy on usage on your computer. You essentially are running everything of the VM plus the tools to run the VM on your computer. With Docker, what you're able to control is the actual development environment you're working in. You don't have to be encumbered by all of the additional extraneous processing that a VM environment has. You're really stripped down to just the bare minimum that you need to have to run the environment using a containerized solution known as Docker. So Docker is essentially an OS level virtualization software. It is a maturity of of the solutions that were started with virtual environments, and there are other solutions out there. Docker has become the de facto container solution that you can use for building out and guaranteeing that what the developer is building is going to be the same as what the operations team will use. So Docker itself is highly scalable and efficient. You can have many Docker environments running on a single piece of hardware. The boot up time is incredibly short. You can reuse the data volumes very, very easily. It's not complicated. And the actual applications are completely isolated. This is like a perfect sandbox environment. So let's dig through the architecture of Docker. So there are really two parts to Docker. There's the Docker engine and there's the Docker client. The Docker engine is comprised of the Docker CLI, which connects with the server daemon. The Docker client will then issue the commands to the Docker daemon. And then the Docker daemon will then interact with your system to be able to provide the tasks and tools needed for you to be able to build out your solution. The actual images that Docker uses are instructions for creating Docker containers. And the actual Docker container itself is a lightweight package that contains all the dependencies needed to run an application. Now, once you have created a container that is of value to your team, you want to be able to store that container so that other team members can use it. And this is where you would use a Docker registry to be able to host and distribute multiple Docker images. So in this video, we're going to go ahead and see how we can get Docker installed and running. So we're going to go ahead and open up our terminal window, and we want to validate whether or not Docker is installed. If you haven't installed Docker, you can actually go ahead and use the following command, and that is to enter in sudo apt install Docker, and that will go ahead and run the command to install Docker. I already have Docker installed on my system, so I'm not going to do that right now, so I'm just going to delete that out. But what I am going to do is check to see what Docker images I have installed on my system. And to do that, I'm going to type in sudo docker images. And when I run this will actually show how many images I have. And right now I don't have any images at all. So why don't we go ahead and install an image. There are two ways you can create an image for your Docker environment. One is to get one from Docker Hub, and the other is to create your own image. Let's go ahead and get one from Docker Hub. And so the command line that we'd want to write is sudo docker pull redis : and after the colon, we're going to actually write the name of the actual file that we're going to be connecting to from Docker. So I'm going to go ahead and go to Docker Hub, and I've already logged in with my user ID and account. So I'm going to go to Docker Hub, and hub.docker.com is the website address, and I'm already logged in with my Simplilearn account. And what you can actually see is different repositories that I have already created below. I'm going to click the Explore button, and I can see the Redis image, and these are all the different commands that I can actually use, all the different variations that I can create. So I can do 5.0, I can do a 32-bit version, I can do a 4.0 version or a 3.8 version, or if I select latest, that will allow me to just pull the latest version even if it's updated. So I'm going to go back to my command line and do latest, and what's going to happen now is that we're actually going to pull the files live over the internet and create the Docker image. So this is going to take just a few minutes. Of course, if your internet speed is faster, then this will happen a lot faster. And here we are. We have everything downloaded, which is great. And so let's just go and check and see if the image has been added to Docker. So we do sudo docker images, and now you can actually see that we have the latest Redis image, and it's given the default image ID, and there's the size of the Docker image, and the tag is latest, so it's the latest version of Redis. And I'm just checking to see if there's any other images running, and no, there isn't. So let's go ahead and now create a container. And so the command for that is sudo docker run -d -p 0.0.0, I think it's .80:80 space redis : latest, and let's run that. Got an error message. Okay, now you know that it's a real demo. This is really live. So I'm just going to clear the screen, and let's write that in again. So sudo docker run -d -p, and it's 0.0.0 0.0:8080 colon latest, and there we are. Everything's up and running. Awesome. So let's just go ahead and check that we actually have the image running in Docker. So sudo docker ps, and there you can see that we actually have the latest Redis version, and it was created 16 seconds ago. We have a new container ID for it, and there's our port that we've created. And let's see if we can view all the running containers, and sudo docker ps-a, and there we are. And we created that container 42 seconds ago. But one of the things you'll notice is the name for the Docker is created automatically by Docker. And here we have Stupefied Engelbarts is the name. Let's change that name to something that's more meaningful for the work that we're doing. So that's actually fairly easy to do, and it's going to be our final task here. So we're going to type sudo docker, and the command is rename, and we want to copy over the old name, and then we put in the old name, and then you do a space, and then you put in what you want the new name to be, in which case we're going to make it Simplilearn. We run that command. That's good. Now let's validate that everything has been changed. So we're going to do sudo docker ps-a, just ps. And there we are. Everything has been renamed. And that gets you started working with Docker. Now let's move on to Ansible. So before Ansible, the ability to be able to deploy software across a network was pretty hard. You couldn't guarantee that your web servers were all consistent and that the database environments were consistent. This was okay if you had a small environment, but once you actually start getting into more complex environments, it became very difficult to manage. Ansible is code that allows you to be able to consistently and reliably create and stand up the environments that you need to be able to store your code for production. So whether or not you require one server environment or you need 1,000 server environments, using tools like Ansible will allow you to be able to consistently deploy out environments that all look the same. So essentially, Ansible is a configuration management tool, and it allows you to be able to deploy automatically to a large variety of environments. The actual tool itself is a push-based configuration tool. It is an agentless tool, so there is no communication coming back about the health of the environment. We actually have tools that we'll cover later on in the video that cover that. Ansible does have a consistency of its product performance, so you know that if you're using Ansible that it's going to work. It's just a very consistent product, and it uses SSH for very secure connections. So it doesn't matter whether or not you have 1 or 1,000 pieces of hardware you're looking to configure. You can actually be rest assured that there will be no security infringement because of the use of SSH. And we look into the architecture of Ansible. It's a very simple architecture. There is the Ansible management node that has playbooks which contain the instructions that you would have for your environment, and that playbook is then pushed out to all the different nodes that contain the hardware that you wish to configure. The actual module collection is the configuration code itself. The playbooks are the instructions of that configuration. And then the inventory is the document of the different groups and the hardware within those groups that you would be pushing out to. So we're going to go ahead and install Ansible onto the system here. And we're actually running our environment in a Linux environment right now. So we have a master environment and a standard node. But we're actually going to go into our terminal window and we're going to do everything on the master node. So the first steps we want to do is actually go ahead and install Ansible, and we're going to do that by installing sudo yum install ansible-y. And this goes ahead and downloads all the files that we need and starts to run the installation. And let's go ahead and see if it's installed correctly. So we're going to type in vi-etc/ansible/hosts, and there we see we actually have a default Ansible hosts already up and running, which is fantastic. And we want to grab this IP address, which is Ansible servers, and then the IP address with the password and root access. And the IP will be specific to your local client. So this is my client system, so if I type in my config, I'll actually see that the IP address matches up, and then you want to make sure that the IP address is correct for your environment. And so this is essentially a node in the Ansible environment, and this is the IP address and the password for that node so we can access correctly. So we're going to hit colon at the bottom of the screen. and take ourselves actually into Ansible. And what we're going to do now is create a playbook to be able to run a sample script. So we're going to call it vi sample.yml. And here we have a sample playbook. We have the name, we have the host, we have the root user, and we have the task. And in the task, you actually see that we're looking to create a virtual web page with the content of welcome, so that we can actually see that the web page is loading. And all of this is written with a very basic XML format called YML, which stands for yet another markup language. But it's very flexible and it's very easy to learn. So let's see if we can go ahead and actually run this playbook so you can actually see it in action. And so we're going to type in Ansible-playbook sample.yml, and this will run the sample YML script -- syntax -check. Then we type in Ansible-playbook sample.yml. So I had some issues there, so I'm going to try that again. And let's go in and write the command again. So Ansible-playbook sample.yml syntax -check, and then run the actual playbook itself. And let's see if it works. Yes, everything's working. And it'll take a moment for everything to initialize. And now what we want to be able to do is go back to our web browser and see whether or not we were able to create that default web page with the word welcome in it. Because that was the command that we created in our playbook. And there we are. There's the word welcome, exactly as we planned. And we can go back and we can review the playbook that we created just to validate that. So let's go back into screen here, and let's go in and look at the YAML page. And there we are. We see that the word welcome is there, exactly as we expected. Now step into our final area, which is network monitoring using a tool called Nagios. So before you had Nagios, sometimes you didn't know whether or not your network was working. In fact, the worst case scenario was when your customers called up and said, hey, your website's not working. The challenges you had is that you didn't know how the usage of the server was being managed. You didn't know whether you were up to 80% usage, utilization on that server, or if you were at 50%. It was difficult to get that information easily. With Nagios, you're able to set up email notifications and other notifications that allow you to stay ahead of issues that you would have within your environment. So with this example, if you're looking for memory utilization, you can receive a notification telling you that your memory is almost full on a particular server and that you should be setting up a new server. In this instance, use Ansible to set up another server. So again, as with the other tools that we've been covering, Nagios is an open source tool, and it's specifically for monitoring systems, servers, and networks within your infrastructure. Very easy to use. It has comprehensive monitoring tools that you can set and control. It is highly available, and it is designed specifically at problem remediation. You want to set it up so that it is the eyes and ears of your network without you having to constantly monitor your network. So the way that Nagios works is that it's just constantly checking out your environment. So the Nagios server is constantly checking the status of your systems, and then is able to create visualization tools of that data. So you can actually then make quick responses. Or you can even send out alerts, such as an email alert or a push notification alert. In this video, we're going to take you through the steps that you need to follow if you want to set up Nagios and the dashboard Nagios provides to help monitor your network. So the first thing you want to do is go to nagios.com, and you can either download the application, or you can actually do what we're going to do here is actually just log into the actual application running on the Nagios website. So for that, you want to go to nagios.na.demos.nagios.com, and you can use the administration or normal user access IDs that Nagios provides. And we've gone ahead and we've actually pre-filled in our ID with Nagios admin and Nagios admin for the user ID and password. Of course, you wouldn't do that in normal real life. So that brings us into the Nagios dashboard. And what you're going to notice is that there are three distinct areas that you should want to focus on. You have the fixed sources, which is all your actual physical hardware that you're monitoring. You have alert summary, summary and abnormal behavior. So let's go check out the fixed sources. And so we have two default fixed sources here, and one in Chicago, one in Tulsa. And you can go ahead and set up additional sources, but what you'll see is that this provides a quick dashboard of the activity in the last 30 minutes, the amount of usage on the disk. You can go ahead and to the behavior tab, and you can modify how you're monitoring and updating the actual source itself. And then the data from these reports will be from these sources will actually be then used in reports, queries, and alerts that you'll use. So we're going to go back to the board, and here you are. There's our two fixed sources. So let's look at alert summary. We're going to expand that out. And the alert summary provides just an overview of the alerts that are being managed. The alerts that you see here are the default alerts that have been created as part of the test environment. It's very easy to create alerts. And in this instance, you can see that the Chicago source is being used to manage the alert. What you can do is when you're actually setting up your own sources, you'll see that the alert will then point specifically to the source that it's pulling the data from. So in the PowerPoint, in the presentation that we just went through, you actually see how Nagios actually is the center of collecting all the information, but it's actually pulling the information from the different networks and environments that you have, and then it stores that data locally to be able to create the visualizations and the alerts. And we have here just a quick overview of an alert here inside of the summary, which actually shows green, which shows that the alert is actually good. Now, there are three different types of colors. There's green, yellow, and red, but as you can see, we have no critical alerts right now. And you'll see the same thing happening in abnormal behavior as well, where it actually goes ahead and shows you the different colors that are available. The thing that's great is that as soon as a warning status is created, then it allows you to trigger an email notification that gets sent out to you and has information in the email which you can then action. So the alerts are very important, and the alerts again are pulling the information from the fixed sources. So the abnormal behavior is just going to zero in and show any specific abnormal behavior that would be happening with your fixed sources. And so in this instance, it's around bandwidth, and everything is green, so everything's looking good. So we're going to the source tab, and we're going to look at the bandwidth graph, and this is a more detailed visualization of the bandwidth that's happening through the Chicago fixed source. Again, you're going to create your own fixed sources, and you'll be able to see the actual usage, such as the bandwidth graph for that fixed source on this screen. And at the bottom of the screen, we have just kind of the most popular information that most network engineers are looking to assess on how a network is being used. So we can go ahead and we can select reports, and we can actually come in and we can either create our own custom report, or you can use one of the many saved reports that are already there. If you're new to Nagios, use the saved reports, because you'll be able to get in and get the great visualization tools that Nagios provides very quickly, and be able to then action the information visually from what you're looking at. These reports are absolutely fantastic, and they're also really good to send to other team members that would have an interest in understanding the network usage and the different areas that you're managing. Now, if you want to get really specific on the type of data that you want in the report, you can actually go in and create a query, and the query can be customized to really however you want it to work. The points of view are very specific insights into different data points that interact, and they're very easy to create. A lot of them have been created, as you can see on the screen already, and as you can see on the left hand side, there's an edit button that allows you to edit and modify those points of view very quickly. Now we're going to go ahead and create one right now, and we're just going to put one in. We're going to put the limiter for an IP address. We're going to change the data lifetime. We can either do hours, days, or weeks. We do 24 hours, that's fine. So we'll just go ahead and we'll see what we have on the screen, and as you can see, there are just a lot already created. Select one, we'll edit the FTP, and we'll see what the data lifetime for that is, and it all looks good. So a query will show all of the saved queries you've created, but you can actually go in and modify a query very easy. You can go in and create a query and really essentially ask it to pull any kind of information that you would be looking at analyzing that has been captured by Nagios. And there's a dictionary you can use that Nagios has on their website that allows you to get better access and understanding the querying constructs you can put together. The alerts, in my opinion, are the most important part because these are the actual actions that interact with the data sources and will trigger alerts that get sent to you. So if we go back to the presentation again, you can see that we're analyzing a lot of data, but it's the data that gets sent to you as an alert that allows you to immediately understand why you need to be able to go in and check out your network. And this is why you're really using Nagios, because you need to have those alerts. And so what we're going to do here is we're going through the steps you use to create an alert, and we're just going to do an alert here that is going to be on analyzing bytes of traffic. And the final step is to actually go ahead and save the alert and really put in what the alert notification model method is going to be. The default is to use an email, which is great, but you can use a Nagios alert or SMP, a simple network protocol alert, or just use a command. Email is definitely the easiest one to use, and so getting started, I would recommend you use email. So we're going to go ahead and we're going to create one. We're going to do one on workflow, and we're going to set up the way in which we're going to manage this. So the threshold is going to be 34 bytes with a critical threshold of 50 bytes, which is very small. I expect an alert to be triggered because of this. And we're just going to use the default emails to send out. And you'll see by default that the new alert is now impending. And the reason why we have it impending is that it's just there to be reviewed by the system to make sure it meets all the standards. I don't think that'd be a problem. And I'm just looking at some of the other different commands we have here. So if we go back, and we can get alerts from other Nagios networks. We connect to different networks right from this configuration screen. Same thing with the SMP receiver. We can use simple network management protocol to connect to other receivers. And the command tab allows us to create scripts that can be triggered from alerts that get created. So you may want to have something that triggers a rebuild of a network environment, which would allow you to authenticate through other systems. Now, of course, there are other things that you can set up in the Nagios dashboard. So, things like information on your profile, defaults here, such as language and your username. You have the same thing for a system administrator, where you can actually go in and set defaults for the sysadmin. There's LDAP AD integration for simple for SAML authentication. Go back to the main dashboard. If we scroll down, you'll actually see that we have an alert has been approved. That's the alert that we created before, and it's now saying critical because more than 50 bytes of information have been sent over our test network in the fixed source of Chicago. Surprise, surprise, 50 bytes is very easy to do. So it's good to see that the system is working correctly. And this is how our Nagios environment works. And from here, the next step is for you to be able to set up and configure Nagios to run with your infrastructure.
So today's topic is Azure Virtual Network tutorial. Let's look into what's in it for you. So we would be covering why is Azure Virtual Network important, what is Azure Virtual Network is, benefits of using the Azure Virtual Network, components of Azure Virtual Network, that includes the subnet, routing, network security group, why these components are required to be created in the virtual network, and how to launch an instance within the Azure VNet or the virtual network. And then we will be seeing one demo in which we'll create Azure Virtual Network, subnets and network security groups. So first of all, let's look into why is Azure Virtual Network important. So why Azure Virtual Network is required? So somewhere far away at an office, a company was struggling with few challenges. The company got a bigger projects which lead to the following challenges. That includes poor network connectivity, time-consuming process in building network topologies, could not divert network traffic to its destination on time. So these were a couple of challenges the company was facing. So the employees thought that what could be the possible solution to these challenges? And then we require the Azure Virtual Network in that case. So first of all, let's understand what is Azure Virtual Network is. An Azure VNet or a virtual network represents your network or environment to run VMS and applications in the cloud. When it is created, the services and virtual machines within the network interact securely with each over the internet. So virtual network, you can consider it as a virtual cloud, which is basically kind of a cloud space virtually assigned to the users or to the organization which they can dedicatedly use for their purpose. So for example, if you have to create some instances or virtual machines onto the Azure cloud and you want to connect it with the on-prem servers, for example, then you might require the virtual network in that case. Let's assume that those instances that are created in the virtual network require the range of IP addresses that you want to allocate to them, and that is something you can customize using the Azure Virtual Network. How do you want that the traffic should be routed to your instances in the virtual network, how the firewall securities should be applied? Everything the end user can control in the virtual network. So it seems like that you are working in your own data center. Ideally, you would be working onto the Azure cloud using the virtual network. Now, what are the advantages of using the Azure Virtual Network? So a couple of them are, it provides an isolated environment for your application. So as I said that, it seems like that you are working in your on-prem environment. That means within your data center. But ideally, it is a virtual space that is allocated to you, which is a kind of an isolated environment that is specifically designed for your task and the activities. Generally, a subnet in a VNet can access the public internet by default. So we create a subnet inside the virtual network which can access the public internet. So there is a public network connectivity that is enabled in the virtual net so that a subnet which will be created in the VNet can be accessed. Traffic can be easily filtered from different resources. So you can have some control lists defined, you can have some security groups created, and how do you want to allow the traffic onto the servers or the application? That is something which you can control. It is a highly secure network, and the security groups and the policies are basically implemented by the end user. So you can design how the security should be implemented. High network connectivity, so you have a higher bandwidth as compared to the normal internet connection you might be having in the data center. Compared to that, you use the Azure network only, which gives you the higher network connectivity. It builds sophisticated network topologies in a simple manner and which is easily manageable, as well as there are less troubleshooting issues that we would encounter. Now, what are the components of Azure Virtual Network? One of them is the subnets. Then you have routing. Then you have network security groups. Now, what do we mean by subnets? The subnet is one of the major or a prime important component in the virtual network. So what you have to do is, first, obviously you would be creating a virtual network. Inside that, you can create the subnets. Subnets, you can consider it a logical partitioning or virtual partitioning inside the virtual network. Subnet lets user segment the virtual network into one or more subnetworks. For example, let's assume that you're working in an organization, and in the organization there are different departments. For every department there should be some set of IP addresses that you want to allocate to the machines that the employees are using, or all the departments should be isolated. That means that they should have their own network IDs and the network addresses allocated to their machines. And in that case, what you would do is you would create the subnets and the subnet IDs that would be allocated to those departments. These subnetworks can be separated logically, and each subnet consists of a server. So what you do is, when you create a subnet, you can create a server or an instance inside that subnet, and how do you want to give an access to that instance depends on criteria or the requirement. Hence, a subnet can further be divided into two parts, one as the public subnet and the other one as the private subnet. These are the naming conventions of the subnet. Then how do you want to give the internet connectivity depends on how the public subnet should be interacting with the internet. And for the private subnet, as the name suggests, that the internet is blocked. So that means it is completely isolated in the virtual network. The private instances, though, if you want that any instance created in the private subnet should have the internet connectivity or an access, you can primarily go with the NAT gateways in that case, which is a network address translation or kind of a translator which converts the private to public and vice versa. And that would actually enable the internet connectivity to your subnets. Then in the public instances, they can directly access the instance. As the name suggests, public instances, that public subnets, that means they have the direct internet connectivity. Next component is routing, and the routing is primarily a routing rules, you can say, that are applied, and those are actually applied to the routers only. So since on the cloud we cannot have a direct router access, and hence using the routing as a component, we can define some routing rules which are directly applied to the router in the infrastructure. It delivers the data by choosing a suitable path from source to destination. For each subnet, Azure Virtual Network automatically routes traffic and creates a route table. When you create a virtual network, automatically a route table is created, and that basically is required to route the traffic, and that can be used by every subnet. That doesn't mean that you only have to create a single route table in the virtual network. You can have multiple route tables also created, which can be associated with different subnets as well. Then you have the network security groups. It is kind of a firewall that protects the virtual machine by limiting the network traffic. It restricts inbound and outbound network traffic depending upon the destination IP address, port, and the protocol. So it is basically the network security group sits on the instances and or virtual machines, and they basically define that how the traffic should be reaching to the ports onto the virtual machine. So how do you want to open up the ports, and for which IP addresses you want to open up the ports? That is something the end user or the administrator has to specify or design. So they act as a kind of a firewall rules only that protects the virtual machines. So how to launch an instance using Azure VNet? So first of all, you have to create a virtual network. So virtual network act as a container for subnets. So first thing is that you would be creating a virtual network. Then you would be creating subnets which are considered as a subset within the virtual network. So cloud instances included in the subnet. So first VNets are created, then the subnets are created, and then you configure the properties in the security group. Have a look at this in detail. Now with respect to the virtual network, what you need to do is you have to create a virtual network in the Azure cloud. Then you have to create subnets into each virtual network, which is kind of a subset of a virtual network. So you can create one as a public subnet, the other one as a private subnet, for example. Now you have to assign instances. So when you create an instance, you have to specify that what is the virtual network, for which virtual network you are creating an instance. Within that virtual network, you have to select that on which particular subnet the instance should be created. And then connect instance to a relevant network security group. So attach your network security group to the instances, and based on the properties or the rules that are defined in the network security group, that will be applied to the instances within the subnets. Finally, configure the properties in the network security and set the policies. As a result, you will be able to launch your instance on Azure within the virtual network. Now we will be seeing one demo that how we can create Azure Virtual Network subnets and the network security group. So just be there to watch our demo on the Azure Virtual Network. In today's session, I would be showing how you can create the virtual networks onto the Azure. And for that, you require the credentials on Microsoft Azure, and here you can see on my screen that I have already logged in into the Azure console. Now what you need to do is, in order to search virtual network, you can type and search in the dashboard, in the search bar, with respect to the virtual networks. And here you can find the virtual network and the gateways. So what you need to do is you just have to click on the virtual networks, and then it will give you the options to add the components inside the virtual networks. So let me first open up the virtual network. Right. Now, in theory, we discussed that the virtual network comprises of multiple components and subcomponents. So primarily is that first you have to create a virtual network. Then you have to assign the IPv4 CIDR block to the virtual network. And then you create the subnets inside the network, which is a subset of the virtual network. Along with that, you define the routing rules. And likewise, you create the instances inside the subnets that will be part of the virtual networks. So that's what we are going to do in this demo. So I would be adding up a new virtual network. So you can see here there are already two virtual networks that have been added. One is the demo VNet, which is by default. So when you created the Azure credentials, the demo virtual network was already created by the Azure so that it can provide you the default settings. And then the test one has been created by me, and that's the customized one, or you can say a non-default virtual network. So I'm going to add another VNet and would define the name to it. So let's wait for the details to appear. So here you have to define the virtual network to create. Obviously we will be going with the free trial only. And then you have to create a resource group. So what is a resource group? It is primarily a collection of resources that share the same lifecycle, permissions, and the policies. So if you have a resource group created, you can use it. Otherwise, you can create a new resource group. So I already have one. That is the demo one. I would be using that. In the instance details, you have to specify the name of the virtual network. So these are certain parameters that you have to go with while defining the name. So let's say I put something like test VNet as the virtual network that I want to create, and that is you have to select a region where you want to get that created. So these are the available regions that you can select. I would go with US East US only, and then we have to define the IP addresses also. So in the IP addresses, the CIDR blocks are allocated to the virtual networks, and that becomes a fixed IP address for that VNet. So what you can do is you can specify a range of IP addresses. Now whenever we talk about a virtual network and the IP addresses, we primarily focus on the private IPs only. So this is the private IP that we are actually talking about. So I can reserve some IP address CIDR for our VNet, and that is the range of 40.0.0.0/16 I'm going to reserve. So now we'll create one subnet, and we'll name that subnet. So as we discussed, that subnets are the subcomponents of the VNet. So here you can see we have already created one subnet with the name public subnet. So likewise we can add another subnet also, and let's name it to something like demo subnet. Right, and the subnet should have the IP address range, and that IP address range should be part of the VNet only. In V18, so same subnet address range you would be defining in the subnet as well. So that will be 40.0.1. or we can select 2.0/24. The rest of the things would be default. We are not attaching any route table as of now, so just click on OK, and here you can see that the subnet is created. Now once the subnet is created, now we are going to create a virtual machine inside that subnet, and for that we'll go to the search bar, and here we'll type virtual machines. Now we'll create a virtual machine in the same VNet, that is the test VNet, and inside the demo subnet, so that our virtual machine gets the private IP address from the subnet that has been created in the VNet itself. So what you need to do is you have to open up the virtual machines, click on add, and here you should add a new virtual machine. So you should select the name of the virtual machine and the network details where we would be defining the VNet as well as the subnet where the virtual machine should be created. So in the subscription we'll go with the free tier, and in the resource group we'll go with the demo that has already been created. We'll put a virtual machine name, something like test VM, and the rest of the things will be default. So we'll quickly skip the disk check also. Now in the networking we would be selecting the test VNet as our virtual network, and in the subnet we would be selecting the demo subnet. So that is the recently one added in the test VNet, and we want that our virtual machine should be part of that subnet only. Now obviously, since we are creating a virtual machine, so it should have the public IP also assigned, since from the public network we need to access those virtual machines. So we'll keep it enabled, right? And the next would be the default settings that we are going to proceed with. So let's review all the configurations and then create your virtual machine. So here you can see that our virtual machine has been created, validation has been passed, and it takes a couple of minutes to get that updated. So let's wait for a few more minutes so that our virtual machine is ready. And primarily what we want to look into is that our virtual machine is created in a correct VNet, and it gets the private IP address from the subnet that has been part of the VNet which has been defined in the creation of a virtual machine. So let's wait for a couple of more minutes and we'll look into the status of the VNet. Now you can see here our test virtual machine has been created. Now what we wanted to look into is that our virtual machine is created in a correct subnet or not, and that is something which we can validate by checking the private IP address. So it got the private IP from the range of the IP address that we have specified in the subnet. Now in order to access this particular virtual machine, you have to use the public IP, since we have to access it from the internet. So from the private IP, this virtual machine will not be accessible. So that's the reason that when we created a virtual machine, we allocated the public IP address also for this instance. So that is with respect to the virtual network and the demonstration on it, and how we can create a VNet and the subcomponents of the VNet, how they are associated or interlinked with each other, and that actually creates a kind of an isolated environment on the public cloud, which gives you the understanding that you can work into just like an on-prem environment only.
In this video, I will take you through what is Azure Active Directory, followed by what is the difference between Windows AD and Azure AD. Then we will look into the services audience, i.e. who uses these services. And at last, we will have a quick demo of Azure Active Directory. So let's get started with the video. First, what is Azure Active Directory? But before getting into the definition of Azure AD, let's have a real-life example of Azure AD to understand it in a better way. There are a lot of pre-created applications that you can offer user access to using Azure AD. So Netflix is one of them. So here's the scenario. You want to share a Netflix account with a dozen people from your organization. Giving your Netflix username and password to everyone isn't safe. So how do you give them access? Here enters Azure AD. The Netflix application is available in the Azure AD gallery and can be added to your Azure AD tenant. This adds the application to your tenancy and allows you to save your Netflix credentials in the secured credential store so that users can be assigned to it. The only people who have access are the ones you give it to, unless they have their own account. You're essentially building a company-wide password vault, then assigning people to the systems. They require access so they can log in without knowing the username and password for those systems. All they need is the Azure AD account or password, and Azure AD will handle the rest. So saying in technical terms, Azure Active Directory is a cloud-based identity and access management service from Microsoft that allows your employees to sign in and access resources such as Microsoft 365, the Azure portal, and thousands of other SaaS apps, and internal resources such as apps on your company's intranet and network, as well as any cloud apps built by a company. Azure AD is required for sign-in and identity protection in Microsoft Online Business Services, such as Microsoft 365 and Azure. If you sign up for any Microsoft Online Business, you will be given access to Azure AD, which includes all of the free services. But what makes Azure AD so different from Windows AD that it has become more popular among people from technical firms? What is Windows AD? Active Directory saves information about network objects and make it easier for administrator and users to find and use their information. It organizes directory information logically and hierarchically using a structured data store. But its supreme drawback is its layers. So let's have a look at its layers and its functioning. First is ADDS, Windows Active Directory Domain Services. Active Directory Domain Services is an example of a directory service that provides mechanisms for storing directory data and making it available to network users and administrators. Second is ADFS, Active Directory Federation Services. Federated identity and access management is made possible by Active Directory Federation Service, which securely shares digital identity and entitlements right across security and corporate boundaries to provide customers, partners, and suppliers with a streamlined user experience while accessing an organization's web-based applications. ADFS extends the ability to employ single sign-on capability accessible within a single security or enterprise boundary to internet-facing apps. Third is ADRMS, Active Directory Right Management Services. Microsoft's Active Directory Rights Management Services safeguards sensitive documents and emails, unlike traditional security methods like firewalls and ACLs. ADRMS encryption and protection remain constant regardless of where a file goes or how it is transferred. But Azure Active Directory actually combines these layers and make the whole process more easier and hassle-free. Azure AD combines these layers into two layers, WAAD, Windows Active Azure Directory, and Windows Azure Access Control Service. Windows Active Azure Directory combines all the problems revolving around identification management. And Windows Azure Access Control Service takes care of federating all the services of an organization. So let's have an example. When an employee joins the premises of an organization, the administrator guides them towards signing to particular services they use and then give access to it. And the employees can access these services through their credentials like username and password. Now that we know what is Azure Active Directory and how it functions different from ADDS, let's have a look at the service audience of Azure Active Directory. Azure AD is majorly intended to IT admins, app developers, and online subscribers. For IT admins, you can use Azure AD as an IT administrator to limit access to your apps and app resources based on your business needs. When accessing critical organizational resources, for example, you can utilize Azure AD to enforce multi-factor authentication. Finally, Azure Active Directory provides you with strong features to help you protect users' identities and credentials while also meeting your access governance requirements. As an app developer, you may utilize Azure AD to add single sign-on to your app using a standard-based method, allowing it to function with the user's existing credentials. Also, Azure AD has APIs that may be used to create customized app experiences based on existing organizational data. For online subscribers, you're already using Azure AD as a subscriber. Each tenant of Microsoft 365, Office 365, Azure, and Dynamics CRM Online is an Azure AD tenant by default. You may begin managing access to your connected clouds apps right away. So now that we know the basic concept of Azure AD, let's have a quick demo of it. So the first thing we need to do is log in our Azure ID account and then go to Azure Active Directory sector. Here you will see add option where you can add a user, group, enterprise application, app registration according to your choice. And below that, you can search for any tenant like for user or for any group. So right now it doesn't belong to any group, or there is no user with this name. Here you will get basic information like their name, what is their ID, what is the license, which groups they belong, and what all devices they use. You can also have an access to their password as well. So let's see what we are going to cover in this video. First, we will understand what is Azure DevOps, followed by features of Azure DevOps. Then we will dive into and explore Azure DevOps services, followed by Azure DevOps Server, and then we will look into the Azure DevOps services and Azure DevOps Server differences. And at last, we will explore Azure DevOps Labs with proper demonstration. So let's get started. So what is Azure DevOps? Azure DevOps enables teams to organize work, collaborate on code development, and build and deploy applications using developer services. Azure DevOps is a culture and set of protocols that brings together developers, project managers, and contributors to collaborate on software development. It enables businesses to create and enhance products more quickly than they could with traditional software development methods. You can use Azure DevOps services in the cloud or Azure DevOps Server on premises. Azure DevOps has built-in functionality that you may access via a web browser or an IDE client. Depending on your business needs, you can use one or more of the following standalone services. Azure Repos. Azure DevOps are built-in functionality. So for source management of your code, Azure Repos offer Git repositories or Team Foundation version control. Azure Pipelines. Build and release services provided by Azure Pipelines to assist continuous integration and delivery of your applications. Azure Boards. Using Kanban and Scrum methodologies, Azure Boards provides a set of agile tools for planning and tracking work, code bugs, and issues. Azure Test Plans. Manual and exploratory testing and continuous testing are among the options available in Azure Test Plans for testing your applications. And at last, Azure Artifacts. This allows teams to share packages from public and private sources, including Maven, NPM, NuGet, and more, and incorporate package sharing into their pipelines. So this brings us to the features of DevOps. First we have is dashboard control. You can rapidly navigate to different regions of the project, build and manage dashboards, and set dashboard widgets using the DevOps dashboard functionality. Then we have improved source control. Git and Team Foundation version control, a centralized client-server system, which are two prominent methods of source control supported by Azure DevOps solution. To observe change history, you can add and manage Azure Git tags, reviews, downloads, and modify files. Following that, we have plan and track your work. You can utilize Azure DevOps systems to track features, requirements, user stories, tasks, issues, and more using a variety of work items. Then we have integrated collaboration servers, a tool that allows teams to collaborate throughout the whole Azure DevOps feature set, including team dashboards, project wiki, discussion within work item forms, and many others. Then we have support for exploratory testing. Manual exploratory and continuous testing are made easier with Azure DevOps, which include workflow customization, end-to-end traceability, criteria-based selection, and real-time visualization that show the test activities. And at last comes continuous integration and deployment. Many developers use CI/CD, and Azure DevOps makes it so easy to do so. Developers may automate various design activities with Azure pipelines, including defining and building association steps, writing test instructions, and managing simultaneous releases. Well, this brings us to Azure DevOps services. You get an integrated set of services and tools with Azure DevOps to manage your software project, from planning to development to testing and deployment. A client or server model is used to deliver these services. Many of them are offered via a user-friendly web interface that works with all major browsers. So source control, build pipelines, and work tracking are just a few of the services that may be managed through a client. You can see the left pane is where you access Azure DevOps services as demonstrated in the figure below. So now that we have covered Azure DevOps services, Let's move on to Azure DevOps Server. Version control, reporting, requirements, management, project management, automated builds, testing, and release management are all capabilities of Azure DevOps Server, a Microsoft product. It provides DevOps features and spans the complete application cycle. So now that we know what Azure DevOps Services and Azure DevOps Server are, so let's have a crisp comparison between them to know how exactly they differ from each other. Despite the fact that Azure DevOps Service is a hosted version of Azure DevOps Server, there are several features that differ. Some functions of Azure DevOps Server aren't available in Azure DevOps Services. So when deciding which platform to use or considering a transition from on-premises to the cloud, keep the following points in mind: scope and scale data, authentication, users and groups, and manage user access. So first is scope and scale data. Azure DevOps Services and Azure DevOps Server are slightly different. Organizations and projects are currently the only alternatives for scoping and scaling data. Azure DevOps Services organization get their own URLs and always have exactly one project collection, whereas deployment, project collection, and projects are the three methods for scoping and scaling data in Azure DevOps Server. Then we have authentication. To connect to Azure DevOps Services using the public internet, depending on your organization's arrangement, you can use Microsoft account credentials or Azure AD credentials to log in. You can also configure Azure AD to require multi-factor authentication, IP address restrictions, and other security features. But you connect to an intranet serving using Azure DevOps Server. Windows authentication and Active Directory domain credentials are used to log in. So this method is completely open and you will never be asked to sign in. Next we have users and groups. You may use a similar technique to grant access to groups of users in Azure DevOps Services. Azure AD groups can be added to Azure DevOps Services group. So you must add users one at a time if you utilize Microsoft account instead of Azure AD. On the other hand, by adding Active Directory groups to multiple Azure DevOps groups, you may grant user access to deployments in Azure DevOps Server. The membership of AD groups are kept in sync, so users gain and lose access to Azure DevOps Server as they are added and withdrawn in AD. And at last, there is manage user access. You manage access to features in Azure DevOps and Azure DevOps Server by assigning users to an access level. Each user in your Azure DevOps Services organization must be assigned an access level. As usual, as Visual Studio subscriber sign in, Azure DevOps Services verifies them. So without a Visual Studio subscription, you can give basic access to 5 users for free. Whereas all use of Azure DevOps Server is on the honor system. Specify the access levels on the administration page to set access levels for users based on their license and assign unlicensed user stakeholder access only. So now that we have covered all the important features and concepts of Azure DevOps, now let's move on to the next very important aspect of Azure DevOps, which is Azure DevOps Lab. The Azure DevOps Lab is a place where you can learn about software development and operations with Azure DevOps services. You can simplify and speed up the DevOps process. It explains how to use Azure DevOps services to automate software delivery and satisfy business requirements. So to understand it in a better way, let's have a demo of Azure DevOps Lab. So let's start with our Azure DevOps demo. So first, what we need to do is navigate to this website, azure.microsoft.in, or we can directly log in through dev.azure.com also. So first, what we need to do is sign into a Microsoft Azure account. So after signing in, you'll be led to this page that you just need to click on continue. And here what you need to do is create an organization under which you're gonna create your projects, multiple projects, and you're gonna attach your team members to it or group members to it whom you want to give the access to your projects. So what is the difference between organization and project is, if you have given anybody access to your organization or somebody is a part of your organization, then that particular individual will have access to all of your projects.
But if you have given somebody only access to your project, then he'll be only restricted to that particular project. He won't be able to access any other project that is present under that particular organization that you both are part of. So basically, organization is something that is used to connect to groups of a related project or somebody who is already a part of a particular organization. So here we will give it a name. So I'm giving simply demo as the organization name. And here you can see that the projects under this organization will be hosted under the South India region, and we need to enter the captcha. And click on continue. Just a second. So now you can see it is saying that it is taking you to an organization. Okay, so we already have an organization of the same name, so let's just change it to something else. Let's give it simply demo org. So here you can see this saying that it's taking to your Azure DevOps organization where you'll be creating your projects. So now you can see your organization name here, and here you just need to create a project name. So I'm giving it simply demo project. Now below you can see visibility. We can opt either public or private. So what is public or private? So basically, if you keep the visibility of the project public, then once you copy this URL, so as I was saying, once you copy this URL into some other browser or incognito mode, you will be able to have the access to the project. But if you keep its visibility private, then only the people who have real access to your organization or to your project will be able to access that project or will be able to see that project or work on it. As you can see, public projects are disabled for our organization, so we can't select public. So we'll go for private and click on create project. Now here you can see the home page of your organization where you have this project, and here you can access the statistics of project, how it is performing, how much time you have contributed to it, or what all services you have added to your project. And down below you will be able to see that there is just one member, which is the root user of this project, and once you start adding more members to your project, their details will be added to this particular block. So now here you can see these are the services, boards, repos, pipelines, test plans, and artifacts services that is provided to you to add to your project. So now let's have a look at them one by one. So first one is boards. As we click on boards, you can see multiple options, your work items, boards, backlogs, sprints, queries, delivery plans. Here you can see it is all empty as we haven't added any service or we haven't worked on a project yet. So let's just click on new work item. So here you can see one is epic, issue, and task. So epic is an option that is you can see a pro option for work items. So basically epic represents business initiative to be accomplished, and it is basically available for basic, agile, scrum, and the CMMI process templates. So what it exactly does is increases customer engagement, that whatever your project is, if it's the engagement of your project, that how it's performing and how it is performing towards the people whom you have given access to the project. Also helps to create new architecture to improve the performance of your project, and it also supports mobile applications. So basically, when you're deploying any mobile application in your project or creating a mobile application as a project, so it will be able to support that as well. Let's click on Epic. So here you can see you need to enter a title for your Epic option. So here you need to add the title of your Epic, like for say we are creating a healthcare or an e-commerce application. So obviously it will be segmented into different parts. Like you'll be having search options or support options or home page. So we just need to give it a name. And here you can see its state is to do. For now we just have to do because we haven't actually created anything in our project and we haven't given any input. So it's in to-do list, and once we start working on it, we can change the state. It can be in progress or completing. So there are multiple states for your Epic. And here you can see the area is simply demo project. That means that we want to assign this search new Epic into this project. And we can also click description over here, that what exactly our new Epic is about. Like for search options, we need to specify or give a description that this is for searching options related to our application. Like for healthcare, one can type medicines or doctors or slots. So that is the thing that we can add in our description, that it will help the user to understand what this feature is about. So this was Epic, and once done we can click on save. So here you can see other stuffs also, like priority. So we can select priority according to our will. So here by default it is priority 2. So priority basically is which function will come first. And here you can mention start date, target date. So once it's done, you can click on save. Now let's move to the next one. Second, what we have is issue. So basically issues are for you to track your work, and epics are used to track the group work and the large scenarios. But this is track like we saw the project statistics, so it will help you to understand the individual progress. So basically issues are raised when you find any obstacle in your progress or in your work. So it can be compared to impediments also. So when you're working with Agile, you need to deal with issues. So by default we have Agile to our project assigned. So like for example, we can see that we have a meeting. So during the meeting, members report if they have encountered any bug or any impediments. So what next we have to do is we have to track them and resolve it. So these are the issues that can one can find, like possibilities. So you can assign here and give it a description again and just save it. So once a user faces these issues, we can keep a track of it, and once it is raised, we can resolve it. Coming to the next one. Next we have is task. So by the name only we can well understand what task is. So a task is a smaller item or smaller segment to track activity that contains all the information needed to accomplish a part of an issue, or you can say user story requirements. So this option is available for basic, agile, Scrum and CMMI process templates. So again we can give it a name, what task we want to assign, and give it a description, and according to that we can select the priority and save it. So the task will be added to your project. We are not assigning any task right now because, as I said, we haven't added any particular project or particular details or application, or we haven't deployed any application yet in our project. So that is why we are not adding anything over here again, because first we need to understand what these services are and what these services are used for. Next we have backlogs. So backlogs helps you to understand the flow of your project. Like today you have contributed 10% of your time, and you have completed the 10% of the work, or you have worked on certain segments of the project, like for say you have worked on the support area. So it helps you to understand and keep a track of the flow of your project, how it is performing and how it is developing and how it is built every day. Next we have is sprints. So sprints are basically a time box intervals that supports your team's ability to work using the agile processes and tools. So what you can do is, whether you're having, let's say you're having a healthcare application, so you just need to have a segment of it and drop it over here. So what it will do is it will get the attention of all the team members. So basically what it does, it makes your project more manageable. It increases the quality of your project and also makes it work even more faster and more frequently once you add the segment to the sprint. So you can say it in one way, it gets the priority and people need to work on it, and it gives your project more flexibility to adapt to change. Now sometimes what happens is many associate Scrum sprints with agile software development. So sometimes agile are often thought to be the same thing. Coming to the next one, we have queries. So the query page basically remembers the view you have last navigated, and when you log in again or when you come back again to the same portal, it returns you to that very particular view only. So you can say that it runs with Azure DevOps command line interface, and all the open like all the pages like you have gone through, you can keep a track of it over here. You just need to click over here all, and you can just see all the queries you have defined in all this while, and also you can share the queries with the team members, so they can also know that where you have been working lately, or which segment you have been working on, or what was the last navigation which you have been going through in this whole project. So it can help you manage your project in a more efficient way and keep a track of how and what all segments you have been working on and what all segments you need to work on in your project. Coming to the next one, we have delivery plans. So here you can see we haven't created any plan yet. So basically, delivery plans are a calendar view of multiple teams or team backlogs or individual backlogs from different projects. So basically, it replaces the delivery plan's marketplace extension, and it is only available for Azure DevOps services. So here you can say it's a summary or time summary of all the projects you have been working on in a particular organization. So now that we have covered both, let's move to the next one, which is repos. So with the name itself, we can well understand that repo stands for repositories. So basically, it is a set of repositories that allows you to control and manage your project code. Like, for say, you're deploying a healthcare application. So these repos options help you create repositories and manage your code of that particular application in a more efficient way. So what you can do is you can connect project solutions by using the repos link. As you can see here, it is shown. So let's look into its option one by one. First, we have files. So in files, your project solution will be available in this section. So repositories can create, manage, and import those solutions. Okay, so you just need to upload your solutions of your code or your project here, and it will just create repositories for it, and it will help you manage those solutions in a better way. And you can see these clone to your computer, push an existing repository from command line, and import a repositories if you want to import any solution. Like here, you can just click on import and add the solution to a repository. So this is what files do. Basically, you can see it's like a physical folder itself where you have all your mini files or repositories or solutions, you can say, of data. So basically, it functions like a physical folder itself. So it helps you keep a track of your codes and everything. Next comes is commits. So in commit section, we can manage commit history for your repositories that you have created in files. So it just commits those repositories with author details from branches. Like for say we have a team, one from support branch and one from management branch. So whoever creates that repositories and adds the solution, it commits that repositories under that particular member of the team with the branch name. Then comes pushes. So push histories are available in this section from each pull request done by the developers. Developers, for say, the team members who have been working on this particular project and creating repositories and solutions. So what is pull request? So pull request or PRs are a way to change or review or merge code in our repositories. So basically, team uses these PRs to review code and give feedbacks or changes, whether for say you are deploying a code or a solution. So one can review them, what all changes needs to be made or what all upgradation needs to be made, or whether the code is already fine or not. So basically, teams use these PRs to review the solutions and codes stored in these repositories, or you can merge multiple solutions or multiple codes into the main branch. So basically, reviewers can step through the proposed changes and leave those comments and vote to approve or reject that particular code, or you can say to upgrade or what all changes we want to make it. They vote for it that whether that needs to be made to that particular solution or not. So these are the PRs. Next, we have branches. So we can manage multiple branching information in this particular section. You can create or release branches from master to dev. Okay, so all users can actually create or release branches from branching information available in this particular section. Next come tags. So tags are used to point out specific commits, like giving message tags and data information to branches. You can create your naming conventions to branches by using commit tags. And the next one is pull request, which we have already discussed. The PRs that are basically used in pushes. So now we have completed repos also. So let's move on to the next one, which is pipelines. So here you can see that we don't have any pipeline created for us yet. So let's have a look at its provided options one by one. So the first one is environments. So basically it is a collection of resources where you actually deploy your application that you're working on. So you can say it contains one or more virtual machines, containers, web apps, etc. Whatever resources you have actually used for deploying your application, or what are services you have used for creating the environment for the deployment of your application. For say we need to deploy our application and it needs an Windows Java environment. So whatever resources you need to create that environment, that will be added to this environment list. It will be listed over this section. Next we have releases option. So basically this pipeline stores the data of your pipelines or stages or tasks and deployments in Azure pipelines, that deployments you have done so far in your applications, for your applications actually. So you can say that it helps your team continuously deliver software to your customers at a faster pace with a very minimum, you can say, lower risk. So you can fully automate the testing and the delivery of your software or applications on multiple stages. Or you can also set up an automated process with approvals and on-demand deployments. Then comes library. So again you can see the page is blank. From the name itself you can scrutinize that it will be a collection of assets from Azure DevOps projects. So basically it is a collection of build and release assets of a particular project. So assets defined in a library can be used in multiple builds and multiple releases pipelines of the project. Okay, so all assets that are defined in a library share a common security model. So you can control who can define new items in a library and who can use an existing item that you have already added in this library. So roles are defined for library items. For say you have added a particular asset or particular item to this library segment, and you can assign a particular member who will be working on this item. Okay, so roles are defined here for these, and these governs the operation you can perform on those items. That person will be keeping track of whatever changes have been made or whatever upgradation has been made to the particular item that has been added to this segment, library segment. So then comes task groups. So task groups are a way to standardize and centrally manage deployment steps for all applications in your projects. So when you include a task group in your definition and then make a change centrally to the task group, the change is automatically reflected in all the definitions. So we can conclude with this that a task group allows you to encapsulate a sequence of tasks already defined in, you can say, build or a release pipelines or into a single task group. So it just encapsulates all those sequence of tasks. So you can choose to extract the parameters from those encapsulated tasks as configured variables and abstract the rest of the task information. So what happens is the new task group is automatically added to the task catalog, and it is ready to be added to other release and build pipelines. So task groups are stored at the project level and are not accessible outside the project group. So the task groups will be only limited to the members who you have assigned in this project, and it won't be accessible to the other people or other team members from different projects, even though they are the member of the same organization. So you can say it's more of a private segment. Now that we have covered task groups, next we have deployment groups. So deployment groups are only available with classic release pipelines, and it is totally different from the deployment jobs. It is basically a collection of deployment related steps defined in a YAML file to accomplish a specific task. So in nutshell, it is a logical set of deployment target machine that have agents installed on each one. The deployment groups represent the physical environment, for example, testing or development or production environment. So a development group is just another grouping of agents, much like an agent pool, you can say. So what you can do with this is you can specify the security context and runtime targets for the agents, or you can let yourself view live logs for each server as a deployment take place. Or you can also enable you to use machine tags to limit deployment to a specific set of servers. So this was about deployment groups. Now that we have covered one more service, let's move on to the next one, that is test plans. So test plans, the first one we have is progress report. So you can analyze with this only. The progress report will be the progress of the project you have been working on, or the deployments you have been doing, or the tasks you have been performing. So basically it lets you analyze and view data for more than one or an individual test plans in a particular project. So data for test plans can be migrated from an on-premises Azure DevOps server that won't show up in this report. Okay. So basically this section lets you drill down by each test plans and give you summary of each test plan in it. So this section also lets you to navigate to a test plan or suite of choice by double clicking on it. Okay. So this was the progress report. Next we have runs. So basically it represents the execution of pipelines. So during a run, the pipeline is processed and agents process one or more jobs. So when you run a pipeline, many things happen under the cover. while you often won't need to know about them, occasionally it's useful to have the bigger picture, right? So Azure pipelines will get processed under this test runs segment. So you'll be able to see what all performance is happening over here. Like while you're running a pipeline, you can see the running state, the date you have started that, or what all that running pipeline includes, like jobs, steps, and tasks. So runs power both continuous integration and continuous delivery pipelines. Next we have load test. So basically Azure load testing is a fully managed Azure service that enables developers and testers to generate high-scale load with custom Apache JMeter scripts and gain actionable insights to catch and fix performance bottlenecks at scale. So basically, application performance and resiliency are more important than ever before. So how you can run an Azure DevOps test? So first you need to click on it and select a test suite that contains all the automated tests, and you can just choose the run test option. And it will start processing it. So this service basically simulates traffic for your application, you can say, regardless of on which platform or where it is actually hosted. So now that we have covered test plans as well, let's move on to the next one, that is artifacts. So this is the last service that is provided to your project by Azure DevOps. So artifacts is a byproduct produced during the software development process. So it mainly consists of the project source code, dependency, or binaries or resources that could be represented in different layout depending on the particular technology. So it's like an extension that makes it easier to discover, install, or publish and Maven packages in Azure DevOps. It's basically deeply integrated with other hubs like Build, so that package management can become a seamless part for your existing workflows. So what is exactly it is used for? So it can be used for both public and private organization with teams of any size. It basically manages your NPM or NuGet packages via feeds, and it allows you to create and share your Maven. So it's a package management solution integrated with your Azure DevOps. So this was all about the services that is provided to your projects. So now that you know what all services do for your project and what are their benefits and how they function, now you can actually plan your project and start creating and working on it and start deploying with the users and what all services you want for your particular project. So what you can do is click here on project setting. Just a second. Yeah, you can just click on project setting. So now what you can do is you can add in description that what your actual project is about. So for say, like I said, if you're creating in a healthcare application, so you can just give it a description that it is for healthcare related issues, queries, and helps needed, and like you're tying that particular application with different hospitals or healthcare organizations. So you can actually add those information in this description. And the process, which basically it is basic or private one, but you do get a range of process for your project when it depending on the visibility of it, like for Agile or Scrum, you can say. So now here you can see that only my ID is attached to it, as I'm the only member here and I'm the administrator. So you can add members here, and scrolling down, you can, now that you know what all services provide you or what they provide to your project, so depending on the need of your project, you can just select the services you want to assign to your particular project. Like, for say, if I don't want boards assigned to it, or you can say if I don't want the services provided by the board, you can just click on it and select remove boards, and I just need to refresh it. So yeah, here you can see I have overview, repos, pipelines, artifacts, but I don't have test plans and boards. As you can see, test plan is basically all the collection of whatever you're managing, which is indirectly assigned to the boards. So as you remove the boards, the test plans also get removed. Okay, and once like this, you can just select what all services you want specifically, and if you want to delete your project, you can just go ahead and delete it. So this was all about the Azure DevOps services and Azure DevOps Virtual Studio, we can say, and how the demonstration of how a project actually functions in this Virtual Studio.
If you are here, you're probably wondering how to become a DevOps engineer. Well, you are in the right place. Today, we are diving into the ultimate DevOps engineer roadmap. DevOps is all about blending development and operations to streamline and speed up the entire software development process. DevOps engineers are in hot demand and the salaries are pretty amazing too. Depending on your experience and where you are, you could be making anywhere from $90,000 to over $150,000 a year. So first up, we have the Software Development Lifecycle, or SDLC. So the software development lifecycle is a process used by the software developers to design, develop, and test high-quality software. It consists of several stages. Each stage helps ensure the software is reliable, functional, and meets user needs. So, understanding SDLC is crucial because it gives you a holistic view of software development. It's like knowing the recipe before you start cooking. So, the different phases of SDLC are requirements gathering, understanding what the stakeholders need, design, planning the solutions architecture, implementation, which is writing the code. Then comes testing, which is ensuring the code works as intended. Then comes deployment, which is releasing the software to users, and finally maintenance, which is updating and fixing the software as needed. So each phase has its own importance, and knowing these phases helps you understand how DevOps practices integrate to make the development and deployment processes more efficient and reliable. So next, let's talk about Linux. Linux is a type of operating system like Windows or Mac OS that runs on many servers, computers, and devices around the world. It's known for being stable, secure, and free to use. But why Linux? Because it's the backbone of most server environments you'll work with. Here are the essentials you should focus on, which are command line operations, shell scripting, learn Bash to automate repetitive tasks, system administration like understand how to manage users, permissions and processes, and package management. So Linux is used everywhere in the server world, and knowing it well will help you fix problems, automate tasks, and manage servers easily. Now the next one is learning a scripting or programming language. So knowing a scripting language like Python, Ruby, or even Bash is essential. These languages help you automate tasks, write scripts, and manage infrastructure. So here's why you should learn scripting. Automation. Write scripts to automate repetitive tasks such as backups, deployments, and monitoring. Configuration management. Tools like Ansible use Python for automation. Infrastructure management. Use scripts to manage cloud resources, databases, and more. So choose a language and start building small projects to get hands-on experience. I highly recommend Python due to its simplicity and extensive libraries. Now, Git is next on our list. Git is the most popular version control system out there. It allows you to track changes, collaborate with others, and maintain a history of your code. So key concepts to learn include repositories, how to create and manage them. Commits, recording changes to the repository. Branches, which is working on different features simultaneously, and merging, which is integrating changes from different branches. So familiarize yourself with platforms like GitHub, GitLab, and Bitbucket. These platforms facilitate collaboration and code management in a team environment. Now, networking and security are critical components of a DevOps engineer's skill set. You'll need to understand how data flows through networks, how to set up firewalls, and secure your applications. So, focus on these areas. Basic networking. Understanding IP addresses, DNS, HTTP, HTTPS, and TCP/IP protocols. Network security. Learn about firewalls, VPNs, and encryption techniques, and application security. Implement security best practices such as input validation, authentication, and authorization. So this knowledge will help you build secure and reliable systems, ensuring data integrity and confidentiality. Now let's move on to cloud providers. So AWS, Azure, and Google Cloud Platform are the big players here. So start with one and learn the basics. So number one, compute services like EC2 AWS, VMware in Azure, and Compute Engine in GCP. Then comes storage services like S3 in AWS, blob storage in Azure, and cloud storage in GCP. And then database services like RDS in AWS, SQL database in Azure, and Cloud SQL in GCP. So understanding cloud services is crucial as most modern applications run on cloud infrastructure. So learn about IAM, which is Identity and Access Management for security, and explore cloud-specific services and tools offered by these providers. Now next, you need Infrastructure as Code, or IAC, which is a game changer. So infrastructure as code is a way to set up and manage computer resources like servers and networks using code instead of doing it by hand. So you write scripts that describe what you need, and then tools like Terraform or Ansible read these scripts and set everything up for you automatically. So this makes it easy to create, update, and keep everything consistent every time. This means you can version control your infrastructure just like your application code. So the key benefits include consistency, which ensure that environments are identical. Then scalability, it easily replicates environments across multiple regions, and then version control, which track changes to your infrastructure over time. So you can start by writing simple Terraform scripts to provision resources or use Ansible to automate configuration management. Now next up, we have microservices and containers. So microservices architecture allows you to break down your application into smaller independent services. So containers with tools like Docker package these services and their dependencies, ensuring they run consistently across environments. So you should definitely focus on microservices, which is understand the principles of designing and building microservices. Then Docker, learn how to create Docker files, build images, and run containers. And then container registries. So use Docker Hub or private registries to store and share images. So these concepts will help you build scalable and efficient applications that are easy to deploy and manage. Now following containers, we have container orchestration. So Kubernetes is the go-to tool here. It manages the deployment, scaling, and operations of containerized applications. So the key components that you need to learn of Kubernetes are: number one, pods. The smallest deployable units that can contain one or more containers is called pod. Next, services. Networking components that define a set of pods and a policy by which to access them. And then deployments, which are controllers that manage the desired state of pods. So learning Kubernetes can be challenging, but it's incredibly powerful. It automates many operational tasks, allowing you to focus on building great applications. Now moving on to next, continuous integration and continuous deployment, or CI/CD, are at the heart of DevOps. So tools like Jenkins, Circle CI, and GitLab CI help automate the process of testing and deploying code. So here's why CI/CD is crucial. Continuous integration automatically tests your code to catch issues earlier. Continuous deployment, it automatically deploys your code to production, reducing time to market. And then pipelines, it defines the steps to build, test, and deploy your application. So mastering CI/CD will make your development process more efficient and reliable, allowing for faster and more frequent releases. So next, monitoring and logging. So monitoring and logging are essential for maintaining and troubleshooting your applications. So tools like Prometheus, Grafana, and ELK Stack, which is Elasticsearch, Logstash, and Kibana, provide insights into your system's performance and help you diagnose issues. So you must focus on metrics, which is track performance metrics like CPU, memory, and network usage. Logging, collect and analyze log data to troubleshoot issues. Alerting, Set up alerts to notify you of potential issues before they become critical. So by setting up proper monitoring and logging, you ensure your systems run smoothly and can quickly respond to any problems. So now DevOps is not just about tools and technologies, it's also about people. So collaboration and communication are crucial. You'll be working closely with developers, operations teams, and other stakeholders, which mean you must definitely focus on communication tools, like start using Slack, Microsoft Teams, or other tools for effective communication. Then comes project management, so utilize tools like Jira or Trello to manage tasks and projects. And then you must develop soft skills, so develop empathy, active listening, and clear communication to work effectively in a team. So being able to convey ideas clearly and work effectively in a team is a key to your success in DevOps. So finally, let's talk about leadership and strategy. So as you grow in your career, you may take on more responsibilities and lead teams. So understanding the strategic aspects of DevOps, such as implementing best practices, driving cultural change, and aligning DevOps initiatives with business goals is crucial. So focus on best practices. Implement and advocate for DevOps best practices within your team. Next, cultural change. Foster a culture of collaboration, continuous improvement, and learning, and then strategic alignment. Ensure DevOps initiatives align with business objectives and deliver value. So leadership skills will help you inspire and guide your team towards success, making a significant impact on your organization.
Do you know, friends, that Kubernetes is also called K8 or Kube? It is an incredibly powerful platform that helps you manage and scale applications automatically. But it can feel complex and overwhelming at the same time. Many people find Kubernetes a bit tricky when they read through the documentation, especially when they are trying to understand how all the pieces fit together to manage containers. In this video, we are going to break it down for you in easy terms. We will explore two types of nodes in Kubernetes, the master node and the worker node. We will talk about how these nodes work together inside the cluster to manage and orchestrate your applications. So guys, without further ado, let's get started. So guys, let's start with understanding first what is pod. A pod is the smallest unit in Kubernetes. It is like a wrapper around your application. Inside a pod, there's usually one or more containers. Now you'll be wondering, what is a container? A container is where your actual application runs. It includes everything that the app needs to function, like code, system, libraries, and dependencies. Containers are lightweight and can be easily moved across different environments, making them very popular in modern software development. You can think container like a box that has your app and everything it needs to run. Whether you run it on your laptop or on a cloud server or inside a Kubernetes pod, the container will always behave the same way. Let me give you one example. Suppose you run an online e-commerce store. You have a front-end web app that the customers see and the back-end, the database that stores the product information and orders. In Kubernetes, you might choose to package the front-end and back-end as two separate containers. So you could run both the web app and the database inside the same pod. In this case, both containers, front-end and back-end, share the same resources, such as memory and network. This might be useful if they need to be closely coupled and always run together. Now, pods are basically responsible for managing resources for containers inside them, like the memory, CPU, and storage. And each pod runs on a node, and Kubernetes decides which node will run on each pod. Now let's understand the Kubernetes architecture. So guys, as we all know that Kubernetes is an open source platform designed to automate, deploy, scale, and manage centralized applications. It provides a powerful way to ensure that your applications are running efficiently and can easily scale across multiple machines, and can also recover if something goes wrong. At the heart of Kubernetes architecture, there are worker nodes and master nodes. These two components work together to ensure your apps are always running smoothly. In this video, we will take a closer look at each of these components and how they interact with each other. So let's understand first the worker nodes. Worker nodes are the machine which can be either physical computers or virtual machines where your applications actually run. Think of them as the workers for your Kubernetes cluster. They execute your app workloads, handle the tasks required them to run. Each worker node in Kubernetes runs these three main processes. That is container runtime, kubelet, and kubeproxy. Let's understand each one of them one by one. The first process is container runtime. The container runtime is like the engine of your worker node. It is responsible for running your applications, which are packaged into containers. Containers are basically lightweight standalone units that contain everything your app needs to run. This includes code, system libraries, and dependencies. The container runtime is a software that ensures these containers are properly managed and executed on each worker node. One of the most popular container runtime is Docker, as you can see all over here. So there are two instances of first, there is a My App, which can be a front end. Then you can consider this as the backend. So guys, you can consider something like this. These two as your two containers. This can be a front end, this can be a backend or database. Now there's a container runtime all over here, which can be Docker in this case. So the container runtime in this case is Docker, and it is ensuring that the container for your web app is running on the worker node. So if you have multiple applications, they will be packaged into separate containers, and container runtime will manage them, making sure they are running as expected. The next process that we are going to discuss about is called kubelet. Kubelet is like a manager that oversees everything happening on a worker node. It talks to the master nodes, which are responsible for managing the entire cluster. The kubelet gets instruction from the master node detailing which application or pods needs to be run on the node. It ensures that these applications are running by managing containers inside the pods. Unlike container runtime, which is specific to managing containers, the kubelet handles the interaction between Kubernetes and the worker node. It is responsible for making sure that the right number of containers are running, that the resources like CPU, memory, and storage are allocated properly to those containers. So you can say, for example, we have the master node that sends a request to the kubelet saying run 2 containers for the web app. So one container is there for web app and one is for the database. The kubelet will check the available resources on the worker node and ensures that the containers are up and running. It also continuously monitors the health of these containers to make sure they don't crash or run into problems. If container fails, the kubelet can restart it based on the policies defined in the Kubernetes, ensuring that the application remains highly available. I hope so you would have got an idea regarding kubelet. Now let's move ahead and understand about kubeproxy. Think of kubeproxy as a traffic director for your Kubernetes cluster. In a distributed systems like Kubernetes, your applications which are running on different nodes, kubeproxy is responsible for managing network traffic and ensuring that data is routed correctly between different services and pods. When your application needs to talk with each other, in this case, kubeproxy sets up the necessary network rules and ensures that the traffic flows smoothly between different pods, services, and nodes. It manages the internal networking of the cluster and ensures that each pod has a unique IP address. Now, let's move ahead and understand about the working of master nodes. While worker nodes handle the execution of the application, master nodes are the brain of the Kubernetes system. The master node manages the overall state of the cluster and makes decisions about which application should run and where they should run. The master node constantly monitors the clusters to ensure everything is working as expected. There are 4 key components that make up the master node. The first one is API server. The API server is like the front desk of the Kubernetes control plane. It acts as an entry point for all the requests you send to the Kubernetes. Whether you are creating a new application, checking the status of your pods, or scaling your app, you communicate with the Kubernetes through the API server. The API server handles all these requests and ensures that they are passed on to the correct components within Kubernetes. For example, let's say you want to deploy a new web application in your Kubernetes cluster. You would send a request to the API server, which will receive the request. It will validate it and pass it to the appropriate components, like it can be a scheduler or a control manager. Now, let's move ahead and understand about the second component, that is the scheduler. If I talk about the scheduler, guys, the scheduler is like a smart planner for the cluster. It is responsible for deciding which worker node should run a new application. When you create a new app in Kubernetes, the scheduler looks at all the available worker nodes and determines the best node for the app to run on. Based on available resources like CPU, memory, and network, the scheduler ensures that your apps are distributed efficiently across a cluster so that no single worker node is overloaded. Now let's move ahead and understand about control manager. The control manager is like the quality control department of Kubernetes. It constantly monitors the state of cluster and ensures that everything is running as it should. If something goes wrong, like a pod crashes or a node goes offline, the control manager steps in to fix it. The control manager is responsible for ensuring that the desired state of the cluster matches the actual state. If you define that you want 3 replicas of an app running and one of them crashes, the control manager will automatically create a new replica to maintain the desired state. Now the final component is etcd, which is also called as the cluster brain. etcd is a database that stores all the data about the Kubernetes cluster. It is often referred to as brain of the cluster because it keeps track of everything, including the apps which are running, where they are running, and the overall state of the cluster. etcd is a distributed key value store, meaning it can store data across multiple machines and ensure that it is highly available and fault tolerant. This is crucial for Kubernetes because the entire system relies on etcd to know how the current state of the cluster is. For example, if you want to deploy a new app, Kubernetes stores information about the app, like its configuration, location, and state in etcd. If something happens to the cluster, Kubernetes can recover the current state from etcd. Now let us look at the example of setting up a cluster. Now that we understand how worker nodes and master nodes work, let us go through a simple example of a Kubernetes cluster setup. In this, you have a basic cluster with 2 master nodes and 4 worker nodes running on it. Let us say these pods contain a web app and a database. You start by creating pods, and each pod contains 1 or more microservices for your web app. Then the scheduler steps in. Once you submit the request to Kubernetes through the API server, the scheduler looks at the available worker nodes and assigns both the pods to your worker nodes. Then comes the kubelet, which manages the pod. The kubelet on the worker nodes receives the instruction from the master node to run on the 2 pods. It starts a container inside each pod using Docker or another container runtime, and it ensures they are running smoothly. Then we have kubeproxy, which handles the communication. The web app pod needs to communicate with the database pod. kubeproxy sets up the network routes and ensures that the 2 applications can exchange data securely and efficiently. Then we have control manager, which ensures the stability. If one of the pod crashes or fails to start, the controller manager detects the issue and creates new instance of the pod, ensuring that both your web app and the database stay online. Then finally, we have the etcd, which keeps up the track. All the information about the state of the cluster, including running pods, their location, their status, is stored in etcd. This ensures that the cluster can recover from any issues and always knows what is happening. So this was a simple example illustrating the cluster setup. Kubernetes is a powerful platform for managing containerized application across cluster of machines. By understanding the roles of worker nodes and master nodes, you can see how Kubernetes automates the deployment, scaling, and management of your apps.
Hello, and in this video, we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problems specific companies have actually had and how they're able to use the 2 different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing 2 primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list.
In today's era of microservices and distributed systems, containerization has revolutionized how applications are built and deployed. One such tool is Docker. Docker is a leading containerization platform which not only helps in packaging applications, but also provides a robust networking features that allows containers to communicate with each other. In today's job scenario, every company is asking you to learn Docker. So for the same, we have covered Docker networking tutorial in today's video. So guys, I have opened official documentation of Docker and we are going to learn about networking. So you would be wondering why Docker networking? So guys, basically Docker networking allows containers to communicate securely and efficiently both with each other and also with the outside world. Networking is a very critical part of containerized applications because in most of the real world cases, applications are not isolated. They need to talk to databases, APIs, microservices, and also external clients. In traditional environments, if I talk about, networking setup and management can be cumbersome or a little bit complex, in which you would be required a complex configuration of firewalls, subnets, NATs, which is Network Address Translation Protocol. But Docker abstracts much of this complexity, providing out-of-the-box networking solutions, which I will show you in today's hands-on tutorial. Now, let us consider one example. So, to suppose, in this typical scenario, you can see the front end is communicating with a backend API. And the backend, you can presume that it is also communicating with some database. Okay, so this is our database. When these services are containerized, so suppose you can see all over here, the front end part is containerized all over here and back end part is put into the container all over here. Now they are communicating internally. So with the help of Docker networking, you can connect these containers in an isolated environment where front end container sends requests to the back end container, which then queries the database. Okay, so with the help of Docker networking, this communication is possible. And we are removing any complex manual network configuration that is needed. So let us see. So suppose we have the front end container, we have the back end container, here is our Docker, and suppose we are using EC2 instance as a host. Now, let us try to understand first what is the difference between Docker and VM networking. Now guys, if I talk about Docker versus virtual machine. So in a virtual machine based environment, each virtual machine typically runs an entire operating system and it has its own dedicated virtual network interface. Okay, these interfaces must be connected to a physical or a virtual switch, and which the underlying technology is a hypervisor. So configuring virtual networking involves setting up IP addresses, subnets, routing rules, and firewalls. For example, if you want to connect two virtual machines, one running a backend service and another running a database. To communicate with each other, you need to assign static IP addresses, configure network routes, and ensure that the firewall rules allow traffic between them. Such of a manual task we have to do. And additionally, if external clients also need to connect to the backend, more routing and firewall configurations are required, which makes this process so complex. But if we talk about Docker networking, then Docker saves us. Docker networking is more lightweight, flexible, and efficient. When you run a container, Docker provides a virtual network interface, or you can say a virtual Ethernet. Okay. Now, this VEth or virtual Ethernet and containers can be connected to Docker's virtual network bridges or custom networks, which we are going to learn a little bit later. In Docker, you don't have to worry about manually configuring subnets, routing, or NAT. Docker automatically handles most of the networking setup for you. With Docker's built-in network, such as default bridge network or user-defined network, containers can communicate with each other very seamlessly. Now, you'll be wondering, how do containers communicate with each other in terms of networking? So let us see this example. So you can see all over here. Suppose we have an application container all over here, and the IP address for this is something like 172.18.0.12. Now, when you initialize the container, the Docker also gives it the IP address, which is the virtual Ethernet network or virtual network, and which we generally called it as Docker 0. Okay. Now, similarly, the host, where you can say it is an EC2 instance, okay, with 192.16.0.12. Okay. Now, just forget it for a moment. Okay, we'll not consider this. So, when app is directly trying to communicate with the host, okay, so nothing is involved. Let me remove this. Now, so in this application, you can see all over here, the IP address for this is 172.18.0.12, and the host with Echo, so Docker has given this a network of 192.16.0.2. Now, when this is trying to communicate with each other, I ask you one question. You can pause this video. Will they be able to communicate with each other? So guys, the answer for the same is no, not at all. There's going to be a network error because they are belonging to different subnets. Now, if I talk about how this problem resolves by Docker, so Docker does what, guys? Docker provides a virtual Ethernet, which is called Docker 0, all over here, and which makes a network configuration. The default one is bridge network, okay? Now, both of them can easily communicate with each other. So say one good example, I want to take it with this. So say you have a login container, you have the payment container, okay? Now, say both of them have a default network configuration in which, say, bridge network configuration. Don't worry about it, we will learn the different type of network configuration. So we are presuming that this network configuration is a bridge network. Okay. Now say login container is a kind of a user-based container where you have to log in through your email, ID, and password. And similarly, you have a more crucial, or you can say more important part of this application is a payment container, which is very, very important. Okay. Now, what you do in order to communicate, so I told you earlier, so Docker does what? Docker creates a virtual Ethernet connection, okay? And this is Docker 0, okay? Now, say we are using the same path, okay? The same payment C with this container, payment container, is trying to communicate with the host through this, okay? Through this Docker 0 network. Now, both of them are trying to communicate with each other. Now, in the payment container, say in this application where user types its credit card number and a lot of other payment details. So hackers can easily exploit it because they are not at all secure, first of all, and they are trying to communicate through the same path. So a hacker can come up and steal some important secrets and data that can be vulnerable for your application. Now, in order to secure this application, guys, we have another scenario. What we do, basically, we need to isolate this from this container. Now, the solution for this is creating your own custom bridge network, okay? So that the IP address for this and IP address for this do not belong to the same category, okay? So this needs to be isolated from each other. So let me show you one more example. So this is a proposed solution in order to do the same. So what we do, basically, so in order for connecting at this network, what do we do? Basically, we are creating our own custom network. That's one of the important features of Docker, which we'll be doing in our today's tutorial also. So now the path is not same. So hackers cannot come and steal your important credentials or data. Now, this is one of the very basic, you can say configuration all over here. Now, this is our next configuration. So this architecture we'll be doing in our today's tutorial. So imagine we have these two containers, login and product, okay? And they are pretty much communicating with each other over the same network, which is Docker 0, okay? So Docker has provided the virtual network for it, and we generally call it by Docker 0. And it is communicating with the host, okay, with the echo of 1.172.16.1.2. Now, the payment process is very, I would say, very critical part of the application where you need to prevent its, you need to keep it isolated. You don't want any of the containers to communicate with this. Now, what you do basically all over here, that you create your custom virtual bridge network which communicates with the host directly. So this payment container is completely isolated from this container. So in this way, you are making this container isolated, and also you're making your application secure. And this is what is the beauty of Docker. Now, what we are going to do all over here, the next part which I want to tell you about the type of network. Since I have discussed you regarding the bridge networking, so let me tell you what exactly a bridge networking is. So say there are three types of networking. Okay, the first one that we have all over here is bridge networking. So Docker creates a virtual network interface on the host with a typical name of Docker 0, as I told you earlier. This virtual bridge connects all the container on the default or user-defined bridge network, which allows them to communicate with each other with the host. And typically, all the containers receive the internal IP addresses from a certain private subnet range, basically, which can be 172.xxx. Okay. So bridge networking is a special type of networking. It's a very default networking, which even if you don't define it, Docker is going to define it for you. And here, your network interface or virtual network interface, you're going to get Docker 0 all over here. That's a basic thing. And bridge connects all the container. Okay, so important part all over here is with the help of bridge. So it connects all the container. Now, how bridge networks work? So let us take this example, what we have all over here. So you can see this is an app container. Okay, say the IP address for this is 172.18.0.12, which is assigned by the Docker. Okay, now this cannot communicate with each other, as I've already told you. So this application container, in order to say our host is an EC2 instance, now in order to communicate this app with this host, you need a bridge network. So that's why here Docker 0 is our bridge network, which is trying to communicate, because they are belonging to different subnets. Okay, they cannot communicate. So for the same purpose, Docker gives us the bridge network. So now, with the help of NAT or Network Address Translation Protocol, these containers can communicate with each other. So this is how our bridge network is working. But the thing with the bridge network is all the containers can communicate with each other. So in this scenario, if I tell you what kind of network they all have, so they are all sharing the bridge network configuration, so that this login container and the product container in a given microservice are easily able to communicate with each other. So Docker 0 is our bridge network, and here you are interacting with the host. Now, if I talk about some of the security concerns with respect to the bridge network, so login and product, they all have shared network. Okay, so all the containers connected to the same bridge network can communicate with each other. But if one of the container is compromised, it could potentially target the other containers also on the same network. So unless additional network policies or firewall rules you have given, this can be a little bit problematic. The second scenario that I can see is access to the host port. So if port forwarding is used to expose the container services, then attackers can potentially target the host machine through the misconfigured or open ports. So these are some of the security concerns with respect to this. Now let us discuss about the host networking. In the host networking, the container bypasses Docker's virtual network interface and shares host machine's network stack. It means that the container does not get its own internal IP address. Instead, it uses the host IP address and the network interfaces directly. This setup is basically useful for applications that require high network performance, low latency, and also a direct access to the network resources. But this is also very, you can say, security concerning. So here, all of them will be communicating through the same network. And the problem which I told you earlier, the attackers can easily come in and steal your important data. So instead of assigning the internal IP address from a private subnet, container directly reaches via host IP address. For example, in this scenario, say Our host has an IP address of 192.16.0, okay, and a container is running with the host networking will be somewhat around 198.61.1.100. So here your IP address is going to change. So if I talk about the IP address for this, it will be using the host IP address. And they all will be communicating with the same network, okay, and which can be a little bit problematic. The security concerns will be more, and the container can use the same network interfaces, ports, and network routing as the host is using. Okay, so you are not assigning any private IP address to this container if you are using the host networking. So in this configuration, we can see there is no network isolation is there. Okay, port conflicts can also happen, like container running with the host networking share the same network namespace as the host. And this means basically that if a container tries to use the port that is already in use by a service, say it is using a port 80 or for a web server, then there will be conflict. So you need to follow careful planning, okay, to avoid these kind of conflicts. Then no NAT is happening all over here. So host networking is not using network address translation protocol. Containers are exposed directly to the host network interfaces, and it reduces the security in this scenario. So for these reasons, host networking is typically not recommended to use in production environments unless or absolutely necessary for performance-based reasons. So I hope so you would have got some idea regarding host networking configuration. Now let us move ahead and try to do the hands-on based on this architecture. So I'll be using a local repo, and in that I will be creating the container for login, product, and I will be assigning them the bridge network. And then I'll be creating my own custom bridge network, okay, so that this security concern does not happen, because if it is using the same, as I've told you earlier, same network of Docker 0, then the attackers can exploit this and steal away your important credentials, which we don't want to happen in our application. So we are creating a custom bridge network, and this will be all happening in our terminal. So let us start our Docker engine and directly deep dive into it. So in our hands-on video, what we'll be going, so we'll be using the same architecture that we have discussed, which is this one. So we are going to create a login container, a product container, and connect them with the bridge network. Then we are going to create a payment container and with a virtual bridge network. And we'll be using the ping command to check from where the communication is happening, which is reachable and which is not. So it's a pretty basic tutorial. Please follow me along. And if you have any doubt, you can pause the video and go back. So container 1 is our login container. This is our product container, and this is our payment. So I'll be using these variables all over here. So let us create our first container, that is container 1. And what you can do all over here, guys, that before creating the container, make sure that your Docker engine is up and running. So all over here, so since I have already created container 1 and container 2, so let me show you. It's going to show me error, but this is a command. So here docker run /t, then -- name, then here is my name of the container, and I'm using Nginx latest, okay, Alpine version. This is a systems image. It is going to create this container 1. Now if I try to enter it, since I've already have this container, now you can see I have got this container ID all over here. Similarly, you are going to get a container ID, but you will not get this error. Okay, so what I can do, I can remove this, okay, with a docker rm command, but I want to use the same variables. So for the same purpose, it's fine. Now, similarly, now let us create our Docker container 2. So we are going to get the ID for this also. So this we have already created. Pretty much fine. Now we have easily created this. Next thing is you need to install ping on your given containers. So what you can do, so if you haven't installed ping on your system, you can go all over here, apt get update y, and apt get install y iputils /ping, which is going to install your ping command. So I have already installed Ping on my system. Now let's proceed with our next thing. In our next process, what we are going to do, we are going to go inside our login container. So all over here, we can type docker exec then it, and the name of the container is container1. Okay, same name which we have given, which is the login container. So container1, then /bin/bash. Okay, now we are inside our container1, and here if I type ping v, so you can see all over here that Ping is not installed on this container. So directly go all over here, copy this command and first update it. So you can see all over here that it has started updating the packages. Now our next command would be try to install Ping all over here. Now let us install the Ping command, and you can see Ping we have successfully installed all over here. Okay, so we have successfully installed Ping on our container. Now let us look at what number of containers we have installed. So you can see all over here we have container 2 and container 1 already created all over here. Now let us move ahead and try to do more configurations. Now let us try to inspect the network for the same. So I'll be using docker inspect command. So let's copy this. So you can see all over here we have the IP address of 172.17.0.5. Just copy this, okay? And we are going to ping this from this terminal, okay? So from the container 1, we'll try to ping it up. So ping, then let's try again, ping. So I'm trying to ping 172.17.0.5. Just click enter, and you can see all over here, okay. So you can see all over here, when I'm trying to ping from this container 1 to product, so by default they have the bridge network configuration. And you can see we are getting the data from the container 2. So easily the communication is happening. This is a TCL handshake with ICMP protocol. And you can see the packets are being transferred. Now, what we are going to do next, we are going to create the next container. So let us go to the next terminal. And here, let us create our next. So, but here, we want to give a custom network configuration. So for the same, what I will do all over here, the same command, docker run d name. So I will just override this, the name of container 3. Okay, and here what I'm trying to do is give a network called secure network configuration, which is a type called of bridge network only. And let us create this. Okay. Now you can see we have got the ID of this. So if I try to inspect this, okay, say docker inspect container 3. So we'll given an IP address all over here, and this is 172.18.0.3. Now if I try to communicate from this terminal, or stop this, okay, if I try to communicate with the container 3, we will see the request will be timeout. So you can see we are not getting any response all over here, because here we have created a different or a custom bridge network which has isolated the container for our payment system. Now we'll see all over here that the request has been timed out. So you can see all over here that we are not getting any information of communication from container 1 to container 3. It's completely isolated. Similarly, what I'll do, let us go to the container 2. So instead of 1, I'll type 2 all over here. And we are into container 2. Now if I try to communicate all over here, since ping is not installed, so let us install the ping first. Okay. Now after that, what you can do all over here, so you can just copy the same command and you can see ping is installed. Now let us try to, let's clear the screen first. Okay. Now when I'm trying to do the ping, so I have again copied this IP address. I'll be moving to my next terminal and so container 2 is trying to communicate with the container 3. So as I have told you earlier that container 2 and container 1 are in the same connected network, which is the bridge network, so that the communication is happening very easily. But container 3 and container 1 and 2 are isolated. So you can see from here also I'm not able to receive any information or any details all over here of the communication between them. So similarly for the same terminal 1, we can see still we are not getting any packets of data all over here. So in this way, we have completely secured one container from the another with the help of custom network that we have created, a bridge custom network, okay, with a parameter called network, in which I have given the name as secure network. So I'll show you the command again. So you can see all over here that we have created a custom container 3. Okay. So the command for giving the network, custom network, was like -- network, then here equal to sign, then here I'm giving my custom network. It is a very easy tutorial, but it's very important for your understanding the concept of Docker networks. So with this simple example, I hope so you would have got a brief idea regarding what is Docker networks, why do we need it, what are custom networks, what are the security things that we need to take care of when we are creating Docker networks with the help of bridge network, and how we can create the custom bridge network. And also we studied regarding the host network, what it is. And I hope so you have enjoyed our today's video on Docker networks.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. And if you're a professional with minimum 1 year of experience and an aspiring DevOps engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in DevOps from Caltech University in collaboration with the IBM should be your right choice. For more details, use the link mentioned in the description box below. So let's start with why are DevOps skills crucial. Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Dockerfile efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Dockerfile creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps project. We deploy applications seamlessly across Azure services like App Service, Virtual Machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamline, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, containerized web app deployment on GKE, scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes Engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, mastering version control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, effortless deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, mastering Terraform project structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently.
Imagine you are at the forefront of your company's shift to the cloud. They need a cloud expert, and you see this as your chance to shine. By earning a Microsoft Azure certification, you can become that expert. With Azure certification, you are not just keeping up with the change, you are leading it. You know how to deploy virtual machines, secure data, and optimize resources. Your team relies on you, and your boss notices your pivotal role in a smooth migration. This certification also boosts your career. Companies everywhere need Azure certified professionals, whether it's a promotion, a raise, or new job offers. Your opportunities expand. The journey itself is rewarding, connecting you with a vibrant community and keeping you ahead of tech trends. In other words, a Microsoft Azure certification does not just boost your skills, it transforms you into a cloud hero, essential to your company's success and your career growth. In this video, we will discuss about the top Azure certification path and how you can prepare for Microsoft Azure certification exams. So what is a Microsoft Azure certification? Microsoft Azure certification encompasses a series of over a dozen credentials designed for professionals in cloud computing or those aspiring to enter the field. Azure is an approach that enables you to innovate rapidly by using cloud-native architectures with loosely coupled microservices, managed databases, AI, DevOps support, and many others. So there are 4 levels of Microsoft Azure certification: fundamental level, associate level, expert level, and specialty level. So the first one is fundamental level, ideal for non-technical individuals starting in cloud computing and cloud professional at the beginning of their career. The next is associate level certification, best suited for candidates with a solid understanding of Azure basics. The third one is expert level certification, designed for those with a strong cloud background, including associate level certification and hands-on experience. The fourth one is specialty certification, focus on specific areas such as Azure IoT Developer, Specialty, and Azure for SAP workloads. So now let's discuss why to pursue an Azure certification. So in the dynamic world of cloud computing, obtaining a certification in platform like Microsoft Azure is a strategic career move. So here are several reasons to pursue an Azure certification. The first one is industry recognition and credibility. The second one is alignment with industry trends. The third one is diverse career opportunities. The fourth one is increased employability and job security. The fifth one is career advancement and higher earning potential. So now move forward and discuss top Azure certification path as per the designation. As you can see this chart, we have three types of levels in certification: expert level, fundamental levels, and associate level. So now let's discuss one by one. So first one is fundamentals level certification. So in this first we have Microsoft Certified Azure Fundamental AZ900. The course fundamentals is designed to teach you the foundational concept of Azure. Crafted by AZ900 certified expert, this course aligns perfectly with the Azure fundamental exam syllabus. The exam format is multiple choice questions, exam duration is 45 minutes, and the cost for this exam is $99. Please note that certification which we are discussing in this video might be discontinued in the future, or their syllabus can be changed. And the second one in fundamentals is Microsoft Certified Azure AI Fundamentals, AI 900. The AI 900 Microsoft Azure Fundamental course is designed to help you learn machine learning and artificial intelligence. This certification is intended for you if you have both technical and non-technical background. Data science and software engineering experience are not required. Exam format is MCQ and exam duration is 45 minutes. The cost for this exam is $99. Next, we have associate level certification. So first one on the list is Microsoft Certified Azure Administrator Associate, AZ104. As an Azure administrator, you often serve as a part of a larger team dedicated to implementing an organization's cloud infrastructure. You also coordinate with other roles to deliver Azure networking, security, database, application, development, and DevOps solution. The skills covered are managing Azure identities and governance, implementing and managing storage, configuring and managing virtual networking, deploying and managing Azure compute resources. Exam format is multiple choice questions and exam duration is 100 minutes. The cost for this exam is $165. The second one we have AZ500, Azure Security Engineer Associate. In this, you implement, manage, and monitor security for resources in Azure, multi-cloud, and hybrid environments. As a part of an end-to-end infrastructure, you recommend security components and configuration to protect the following: identity and access, data, application, networks. Your responsibilities as an Azure security engineer include managing the security posture, identifying and remediating vulnerabilities. Exam format is multiple choice question, exam duration is 100 minutes, and the cost for the exam is $165. The next we have AZ204, Azure Developer Associate. You are responsible for participating in all the phases of development, including requirements gathering, design, development, deploying, security maintenance, performance tuning, and monitoring. You should be proficient in Azure SDK, data storage options, data connection, APIs, app authentication, and authorization. As a candidate, you should have at least 2 years of professional development experience and experience with Azure. Exam format is multiple choice question, exam duration is 100 minutes, and the cost for the exam is $165. The third one we have expert level certification. So the first one is we have Microsoft Certified DevOps Engineer Expert, AZ400. As a DevOps engineer, you are a developer or infrastructure administrator who also has subject matter expertise in working with people, processes, and products to enable continuous delivery of value in an organization. Your responsibilities for this role include delivering Microsoft DevOps solutions that provide continuous security, integration, testing, delivering, deployment, monitoring, and feedback. You must have experience both administrating and developing in Azure with strong skills in at least one of these areas. You should also have experience implementing both GitHub and Azure DevOps solution. The exam format is multiple choice questions, exam duration is 150 minutes, and the cost for the exam is $165. The second one we have Microsoft Certified Azure Solution Architect Expert AZ305. Your responsibility for this role include advising stakeholders and translating business requirements into design for Azure solutions that align with the Azure well-architected framework and cloud adoption framework for Azure. In this role, you implement solution on the Azure by partnering with various other job roles, including developers, administrators, security engineer, data engineers. So as a candidate for this certification, you should have advanced experience and knowledge of IT operation, including networking, virtualization, identity, security, business continuity, disaster recovery, data platform, and governance. You should manage how decisions in each areas affect an overall solution. Exam format is multiple choice question. Exam duration is 160 minutes and the cost for this exam is $165. So as we conclude our Azure certification roadmap, we have covered the significance of Azure certification and delve into the fundamentals, associate and expert level.
I would like to welcome you to this Azure interview preparation session. Knowing Azure is one thing, having worked on Azure is another thing, and being able to answer interview questions in Azure is a totally different thing. Although one helps the other, it's still different skills. And our aim through this video is to prepare you with common product and scenario based interview questions. So why wait? Let's get started. A common cloud interview question is, what's the difference between SaaS, PaaS and IaaS? We all know that a software as a service is thin client model of software provisioning, where client in this case usually is simply a web browser providing the point of access to softwares running on the servers. Now SaaS is the most familiar form of cloud service for customers. SaaS moves the task of managing software and its deployment to third-party services, meaning the vendor actually gets to manage all that. So SaaS is software as a service involving applications being consumed and used by organizations. So it's generally using an application, and usually organizations pay for their use of this particular application. Now some examples of SaaS would include Office 365. Salesforce is another very good example of SaaS, and a lot of Google apps and storage solutions like Box and Dropbox are a very good example of software as a service. Talking about platform as a service or PaaS, it actually functions at the lower level than SaaS. Now, typically it provides a platform on which software can be developed and deployed. Now here we develop the software, we deploy the software. Now PaaS actually provides an abstract of much of the work dealing with servers and giving client an environment in which the operating system and the server software and the hardwares and the network are managed and taken care. In other words, with a platform as a service, all the things that I've mentioned, like the servers, the server software, the hardware, everything is managed by the provider, and we can focus on business side of the scalability, and we can focus on application development of our product or the service. So in short, platform as a service is a service that enables developers to build and work with applications without even having to worry about the infrastructure or management of the underlying hosting environments. And some examples of PaaS in Azure is SQL and Azure Storage. Talking about infrastructure as a service, IaaS, now this is moving down the stack even further. Now we get to the fundamental building block of the cloud service, which is infrastructure as a service, IaaS. Now IaaS is fully of highly automated scalable computer resources. IaaS is full of storage. IaaS is full of the network capability. That's what IaaS is. Now IaaS clients have direct access to the servers and storage, just as they would to do traditional servers. But in this case, it's going to be in the cloud. In this case, it's going to be more scalable. So IaaS is very similar to what you would do in your on-premises physical data center. But when we talk about IaaS, we get to do everything, but it's stored in the cloud. So if we need to build a definition around IaaS or infrastructure as a service provides users with components it provides components. It does not give us a built environment. It simply provides a component such as operating system, networking capabilities, and a lot more. Now this is a paid for based on the usage and can be used to host applications. In other words, this is pay as you go type. The more you use, the more you pay. The less you use, the less you pay. And some of the examples of IaaS in Azure is virtual machine. That's a great example for IaaS, and VNets for networking. That's another good example for IaaS in Azure. Another common question in Azure interview is, what are the instance types offered by Azure? The main intention of this question is, how well have you understood the different offerings in Azure, and how well are you trained to pick the right offering for the right service? Now, one size does not fit all, and there are a lot of services in Azure that under the carpet it does the same thing, but depending on how different your requirement is, we'll have to pick the appropriate service. So this question, what are the different instance types offered by Azure, it's to test how well have you used the product and services available in Azure, and how well have you applied them for the given requirement. You shouldn't be provisioning more, you shouldn't be provisioning less at the same time. So it's kind of matching the right service to the right requirement. So what are the instance types offered by Azure? As you see in the list, we have general purpose, compute optimized, memory optimized, storage optimized, GPU virtual machines, and high performance compute virtual machines. Now, answering just the names won't be enough in an interview. You'll have to go further and explain why and in what scenario you would use general purpose, and what are the use cases, what type of servers is a good fit for general purpose, and what type is a good fit for compute optimized, so on and so forth. And that's exactly what we're going to do now. So the general purpose VMs, they provide a balanced CPU to memory ratio, and it's very good for testing, very good for a development environment, very good for small and medium databases, and also for low to medium traffic web servers. And some of the use cases are, like we said, test servers, low traffic web servers, small to medium databases, some enterprise grade applications. It's also good for relational database. It's also good for servers used for in-memory caching. It's also good for some small analytic database, very good for microservices. And if you're trying to build a proof of concept for an idea that you just have or just parked, this is another good server for doing proof of concepts, because you're not going to send actual traffic to it. I just want to show that your idea works. So general purpose server is a very good use case for those scenarios. And the largest instance size we can get in general purpose is standard D64 V3. Which comes with 256 gigabit of memory and 1600 gigabit of SSD temporary storage. On the other hand, compute optimized VMs have a high CPU to memory ratio and are very good for medium traffic web servers, very good for batch processing servers, very good for application servers. Now, because it's compute optimized and compute means CPU, it's an excellent choice for workloads that demand faster CPU, but does not need as much memory or temporary storage virtual CPU. Some of the workloads that run very well on compute optimized are analytic workloads, gaming servers require more CPU, they run really well. Batch processing are some of the applications that can be placed in compute optimized, and by doing that we get the actual benefit of the compute optimized instance. And the largest instance size, or the largest instance size type, is standard F72's V2, and here we get 144 gigabit of memory and 576 gigabit of SSD temporary storage in compute optimized VMs. In the same lines, memory optimized VM, they offer high memory to CPU ratio, and that are great for databases. Databases require more memory, so it's a great fit for a database, and it's a great fit for medium to large scale caches, applications that require in-memory analytics. So this memory optimized, memory is more, so it's very good for in-memory analytics applications. And the largest instance size we get here is standard M128M, and look at the gigabit of memory. It's 3892 gigabit of memory, and look at the temporary storage. It's 1400 336 gigabit of temporary storage. On the same lines, storage optimized. Now I guess I don't have to explain to you what storage optimized is used for. You might have easily guessed looking at the flow. Yes, storage optimized VM offer high disk throughput and I/O and are very ideal for big data, SQL, NoSQL databases, data warehousing servers, large transactional databases, and a lot more. And some of the examples of the applications that can be launched on storage optimized are Cassandra, MongoDB, Cloudera, Redis. These are some familiar applications that can get benefited when we run them on storage optimized. And one difference between storage optimized and the other servers are they are generally optimized to use the local disk on the node attached directly to the VM rather than using an durable disk, which is actually a remote disk space. Now what does this allow? This allows for greater input outputs per second or throughput for the workload. So that's what we get. A greater throughput, a greater input outputs per second is what we get when we use storage optimized. And the largest instance size available in storage optimized is standard L32S, and the memory is 256 gigabit. And look at the temporary storage, it's 5630 gigabit of temporary storage. GPU type VMs, easy to guess. GPU optimized VMs are specialized virtual machines available with multiple GPUs attached to them. Now these sizes are designed for, or these VMs are designed for compute intensive, graphic intensive visualization workloads that require a lot of graphical processing unit attached to it. So in short, these are virtual machines that specialize in heavy graphic rendering and video editing. It also helps with model training and interferencing with standard ND24RS, which has 448 gigabit of memory and 2948 gigabit of temporary storage. And the last but not the least, but the best, is high performance compute or Azure H series virtual machines. Now they are the latest in high performance computing VMs and are aimed to handle workloads like batch processing, analytic, molecular modeling, and fluid dynamics. A lot of complicated applications in this VM. And this is the fastest and powerful CPU virtual machine with optional high throughput interfaces. And the largest instance size that's available is standard L32S, which comes with 224 gigabit of memory and 2000 gigabit of SSD temporary storage. And a third common question is, what are the deployment environments offered by Azure? There are two main deployment environments. One is the staging environment and the other one is the production environment. Now in staging environment, let's talk about staging first. So when you're deploying a web app or web app on Linux, you can deploy them to a separate slot instead of the default production slot when running them in standard premium or isolated app service plan tiers. Now the deployment slots are actually live app with their own host name. And at a later point, the staging environment can be swapped with the production environment. So why do we need a staging environment? What are the benefit of it? So the benefit of deploying our application to a non-production or staging environment, it provides a platform to validate changes to our application before it can be made live in the production environment. And in the staging environment, the app can be identified using the Azure's global unique identifier, also called as the GUID URL. And it's very similar to the production URL, except that it has a custom name in front of it that identifies it as the staging environment. And for production environment, this is the live production environment that's serving customers' requests, that's serving the customer content. Now it can be slightly different from the staging environment in a way that the URL that's used to identify the production environment, that's more of an DNS friendly name, like the name of the actual service.cloudapp.net. That way it differs. In case of staging environment, you have a custom name right before it, so the custom name and then the cloudapp.net, but in this case you get the direct service name as the name of the URL. So this is live production environment which receives and handles and serves customer traffic. Another commonly asked question in Azure is what are the advantages of scaling in Azure? The actual thought behind the question is to see how much have you understood scaling, how much have you seen and how much have you applied the scaling effect in the production environment and have received benefits in return. So let's talk about it. Advantages of scaling in Azure. Some of the advantages are we get the maximum application performance. Now auto scaling is a built-in feature for the cloud services, be it AWS, Azure, Google, and a couple of other cloud service providers. It's a built-in feature for a cloud service. A cloud service should be auto scalable. And that includes mobile services, virtual machines, and when we run our applications on mobile services or virtual machines, the website actually gets the best performance during the change in the demand. Again, different applications might require different performance needs. For example, for some apps, the performance is measured based on memory. And another good example is the fluctuating demand. For example, you could have a web app that handles millions of requests during the day and literally nothing at the night. And auto-scaling this environment, any of these environment will automatically scale or fatten your environment so to receive all the incoming traffic, and during lean period it actually gets slimmer and slimmer so to help you with the cost. So it actually maximizes the performance. That's what auto scaling does. And like we said, auto scaling scales up and scales down based on demand. It not only scales up but also scales down so to help you with the cost. And if you know the particular pattern in which the application is going to receive traffic, then we can very well go ahead and schedule scaling to our application or schedule scaling that infrastructure based on time. If we already know that Monday to Friday, that's the traffic that I would get, and it's a constant one. It's not a public facing, but it's an internal application. So I know all the 500 users or the 1,000 or the 5,000 users who will be using it. So at any given point, it's just 5,000 users. It's not going to go beyond that. And during Saturday and Sunday, literally nobody's going to be in office. So no load at all. So in that case, I pretty much know how the pattern is going to be. I can go for scheduled scaling if I know the pattern. And auto scaling, like I said, not only helps with keeping the application highly available, it also helps with the cost effectiveness of our infrastructure. So anytime there's a VM or a group of VMs running on less CPU, auto scaling is going to actually get the environment slimmer and slimmer, so we're not unnecessarily running any resources and paying for it. If you're being interviewed for the infra side in Azure, this is another common question that gets asked. How are Windows Active Directory and Azure Active Directory different? Let's talk about the Windows Active Directory first. The non-cloud Windows Active Directory the service was released along with Windows 2000 Server Edition, and this Active Directory is essentially a database that helps organizations to organize the users, organize the computers, and a lot more. It provides authentication and authorization to the applications. Not only to the applications but also to file servers, to printers, and a lot of other on-premises resources. That's what the basic non-cloud Active Directory does. On the other hand, the Azure Active Directory is not designed to manage web-based services. The Azure Active Directory, on the other hand, was designed to support web-based services that use REST API interfaces for Office 365, Salesforce.com, etc. Unlike the plain Active Directory, this uses a completely different protocol. So protocol-wise, it's different, and the services that it supports is quite different. Now, besides that, it also has a couple of other differences as well. And let's look at them. So the actual Active Directory or the Windows Actual Directory is a directory service that facilitates working with interconnected, complex, and different network resources in a very unified manner. On the other hand, Azure Active Directory is Microsoft's multi-tenant, cloud-based directory and identity management service. And the Windows Active Directory has 5 layers to store data, to store user details, and to issue the management certifications. On the other hand, Azure Active Directory integrates or compresses the 5 layers into just 2 layers. Here, Windows Active Directory works with on-premises servers like applications, file servers, and printers, etc. On the other hand, Azure Active Directory, it works on web-based services that use RESTful interfaces. If you're being hired for the development environment or for the cloud DevOps support environment, or even for the production support environment, you might find yourself being asked this question: what are the types of queues offered by Azure? Now, Azure supports 2 types of queue mechanisms, the storage queue and the service bus queue. Let's talk about storage queue first. Now, the storage queue, which are part of Azure storage infrastructure, it provides a simple REST-based interface, simple REST-based get, put, and peek interface. It provides reliable, persistent messaging within and between the services. It follows the pub-sub model or a pub-sub messaging infrastructure, and it's best suited for users that need to store more than 80 gigabyte of messages in the queue. It can provide logs for all the transactions executed against the user's queue. So that's what we get with storage queue. And on the other hand, service bus queue, the service bus queues are built on top of broader messaging infrastructure, and they are designed to integrate applications and applications component that can span multiple communication protocols. So that way it differs. So this is good for applications and components that may span multiple communication protocols and even totally different network environments. So in short, these service buses or the service bus queues in Azure are part of Azure's messaging infrastructure, and they integrate applications or application components that can actually span multiple different protocols and multiple different network environments. It also provides an first in, first out style for delivery, and the user's queue size has to remain under 80 gigabit. Another familiar question is, what are the advantages of Azure Resource Manager? Now, the Resource Manager helps us to manage the usage of the application resources. This question is actually to test how well have you tested, how well have you used Resource Manager and have gotten the benefit of it. This question actually tests how easy it has become after the introduction of Resource Manager compared to when doing deployments or when provisioning resources without the Resource Manager. So let's get into the answers for the question. What are the advantages of Azure Resource Manager? In short, Resource Manager is called ARM. So the ARM helps deploy, manage, and monitor all the resources for an application, a solution, or a group. So all the interconnected application, all the interconnected services can be monitored as group using Resource Manager. And users can be granted to access to resources that they require within a Resource Manager. So in an account, I can have like 10 different resources created by a Resource Manager or a resource group created by Resource Managers, and I can allow, deny connection to those services or only to those services based on whether the user should be accessing one and not accessing the other. So that way it becomes easy to give access to a group of application. It helps in getting billing details for the group of resources. Now, which group is using more, which group is using less, and which group has contributed more to this month's bill, stuff like that. So those details can be obtained using Azure Resource Manager. And provisioning resources is made much easier with the help of this Resource Manager. Another question is, how has integrating hybrid cloud been useful for Azure? Well, with the use of hybrid cloud, we get the best of both the worlds. So what's hybrid cloud? It's nothing but combining the public cloud and the private cloud and allowing data and applications to be shared between them. So whenever the compute or the processing demand fluctuates, hybrid cloud computing gives businesses the ability to seamlessly scale their on-premises infrastructure in the public cloud and handle any kind of overflow in the requirement or overflow in handling the application. So it really helps. It boosts the productivity of our on-premises application. So with the hybrid cloud, we get a greater efficiency with combination of Azure services, DevOps processes and tools for the application running in on-premises. And by having a hybrid cloud environment, users can take advantage of a constantly updated Azure service and other AWS marketplace applications for their on-premises environment. And the other benefit is with hybrid cloud environment, we can simply deploy applications regardless of its locations. In case of on-premises, we'll have to worry about the location, but when we expand our on-premises environment in the cloud, and we can pick any of the locations and simply deploy it in them. And this enables the applications to be created at a greater speed. What's federating in Azure SQL? Now this question is very specific about SQL. How can we scale the SQL database? Now this is a very good question, or a valid question, or an important question in the interview, because many customers or companies have not been able to meet the user demand because they could not scale out the databases. The theory of scaling out or adding servers to accommodate the increased workloads and traffic is not hard to understand, but the implications can be very complicated. The implications can be very expensive. We're well aware of scaling the web servers, that's very common, but how do we scale the database? So Microsoft provides the tools and technologies so we can scale out the database in the cloud, and that's what is called SQL or federation in Azure SQL. So the way we scale out the SQL database is by sharding the database. So sharding actually enables users to take advantages of the resources in the cloud. Not only that, it allows users to have their own database or a shared database amongst each other. Because we're creating a highly available database, because we're having shards in a database, it actually reduces the possibility of a single point of failure for our database. And more importantly, because we're sharding, because we're using federation in Azure SQL, it provides an cost-effective scaling of our databases by using cloud resources, or by using billing only for the cloud resources that we have used. So no pre-provisioning, no over-provisioning. It provisions the right amount and we pay the right amount. Let's talk about this one. What are the different types of storage offered by Azure? Now the different types of storage offered by Azure are, as you already know, and as you can see, they are Azure blob storages, table storages, file storage, and queue storage. So let's expand one after the other. Now blob storage are nothing but a massive scalable object storage, and that's very good for storing text and binary data. And Azure blob storage is Microsoft's object storage solution for the cloud. Now, blob storage is optimized for storing massive amount of unstructured data that can be in form of text or in form of binary data. So in short, blob storage enables users to store unstructured data, and those data can be in the format of pictures, music, video files, and a lot more. And it stores them along with their metadata. And another advantage or another feature benefit that we get from blob storage is when an object is changed, it is verified to ensure it is of the latest version, number one. And number two, it provides maximum flexibility to optimize the user's storage needs. And this unstructured data is available to customers through an URL or an REST-based object storage. So they are the benefits that come along with the blob storage. Table storage, on the other hand, is a NoSQL store for schemaless storage of secured data. Now this Azure Table Storage is a service that stores structured NoSQL data in the cloud. And because this table is schemaless, it's very easy to save your data. It's very easy to adapt your data as the need for your application grows. And this table storage is very fast and cost effective for many type of applications. So some of the type of data that we can store is table storage is good for flexible databases like user data for web applications, address book storage, device information storage, and if you want to store metadata, this is a very good use case to store them in Azure Table Storage. Azure Files is another storage. Here it's a managed file share for cloud or on-premises deployment. So file storage provides file sharing capabilities accessible by the server messaging block protocol, and this can be accessed from the cloud and this can be accessed from on-premises as well. Here in file storage, the data is protected by SMB 3.0 and HTTPS protocols. And the more important thing is Azure takes care of managing hardware and the operating system deployments for Azure file storage. So this additional file storage can be used when we want to burst the storage capacity in on-premises. So on-premises, the primary, and cloud is the secondary or the extended on-premises storage. So it actually improves the on-premises performance and capabilities for our on-premises data center. And then we have queues, Azure Queues. It's a messaging store for reliable messaging between the application components. So we spoke a little about this in the previous question. So the Azure Queue Storage is a service for storing a large amount of messages that can be accessed from anywhere in the world via HTTP or HTTPS protocol. In here, a single message can be up to 64 kilobits in size, and in a queue we can have millions of messages, and the limit can actually go up if we have not reached the limit of the storage account. So it's millions and millions of requests that can be stored in the storage queue or the queue storage. So the queue storage, in short, provides message queuing for large workloads, and it enables users to build flexible applications and separate the functions one from another, so one failing doesn't affect the other application which is running healthy. And this queue storage, it ensures the application is scalable and less prone to individual component failures because they are decoupled, separate now. It also helps in monitoring the queue, which ensures the customer's demands are met. So queue is a great place to monitor, or a great component to monitor, so we understand how much peak have we reached for a particular application, service, or a container. What is text analysis API in Azure Machine Learning? Now, text analysis is actually an cloud-based analytics API, and it provides an advanced natural language processing over the raw text. And it has got 4 main functions, like the sentiment analysis and the key phrase analysis, language deduction, and a few other things. Now, what do you mean by sentiment analysis? Now, sentiment analysis is from the logs, from the comments, from the text comments that we receive, do an analysis and find out whether that's a positive or a negative statement. Now, if it is the API returns an sentiment score between 0 and 1, and 1 is positive and 0 is negative. And then in text analysis, we have a key phrase extraction, which is it will automatically extract the key phrase to quickly identify the main points in that key phrase. For example, if you're analyzing a text which says the food was delicious and there were wonderful stuff, then the API returns the main talking points of that phrase, like food is the main talking point, and wonderful stuffs, that was a main talking point. So that's another feature that this text analysis has. And then we have language deduction in text analysis, right? Irrespective of what you paste, it can try to gauge and try to align it to the 120 or up to 120 languages that it supports. So I can simply take text from the internet and I can paste it, and text analysis software is going to identify the language and then can run phrase and sentiment analysis on those texts. Right. So in short, text analysis is an API, a set of web services that can be used for text analysis. It can be used to analyze unstructured statement, sentiment analysis, key phrase extraction, and a lot more. And the results are generally between 0 and 1, and 1 being positive and 0 being the negative sentiment. There is no much training, or in other words, this is not as complicated as a couple of other text analysis softwares are available in the market. We can simply paste, we can simply upload the text, and we can call the service and it runs a sentiment analysis on it all by itself. Let's look at this question. What are the advantages of Azure Queue Storage? If you're going to work in a development environment, if you're going to work in an environment that embraces DevOps, this could be a question. What are the advantages of Azure Queue Storage? Now, Azure Queue Storage is built to flexibly operate the applications and separate the functions between the applications that run large workloads. So when we design applications for scale, these applications can be decoupled. so that they can scale independently. And thing happening on an application is not dependent on another application, and anything happens to a section of the application will not affect the other application because they are now decoupled and connected through the queue storage. So the queue storage gives us asynchronous message queuing for communication between the applications, irrespective of whether they are running in the cloud or whether they are running in desktop or whether they are running on premises or on mobile devices. So in short, this queue storage enables message queuing for large workloads in a simple and cost-effective and a durable manner. Talking about the advantages is it provides rich client libraries for Java, Android, C++, PHP, Ruby, and a lot other services getting added during every new release from Azure. And the main advantage again is it enables users to build flexible apps and separate the functions for bigger or greater durability. Again, introduction of queues into our application, it ensures our users' applications are scalable and less prone to individual component failures, meaning one component failing is not going to take the whole application down, right? If one component fails, it's just that component that fails. The rest are healthy and the rest are going to function. It also helps us to monitor the queues and ensure the servers aren't overwhelmed by sudden traffic bursts. So how much do I have in the queue kind of determines the traffic for my application. And if the queue is more, I can always go and auto scale my environment, and the queue is less, I can always go and shrink or make my environment thinner so it can save cost. And anytime there is more data in the queue, I can auto scale, monitor the metric and do auto scaling based on that metric. So the environment knows that there are more data coming in. I need to expand myself to handle that much amount of data. This is a very common question. What are the two kinds of Azure Web Service roles? Now, a service role is a set of managed and load balanced virtual machines that work to perform some task. And based on what it's going to run on top of it, is it going to run a web service or is it going to run a worker service, defines what kind of roles that gets attached or that goes on this virtual machines. So we have two types, web role and worker roles. The web role is a cloud service role that's configured to run web applications developed on programming languages, technologies. And majorly they support IIS, Internet Information Service, and they support ASP.NET, PHP, Windows Communication Foundation, and so on. So that's web roles. And these web roles, it automatically deploys and hosts application through the user's IIS, Internet Information Service. On the other hand, worker roles are roles that runs applications and service level tasks which generally do not require IIS. So IIS is actually the differentiating factor. So in worker roles, IIS is not installed by default. The worker roles are mainly used to perform supporting background process along with web roles and do tasks automatically compressing or uploading the images, running scripts, and or doing some changes in the database, getting new messages from the queue and processing, and a lot more. The work, the applications, or the work that does not require IIS. That's what this worker role does. Again, the main difference between the web role and the worker role is that the web role automatically deploys and hosts your application through IIS, whereas the worker role does not use IIS and runs our application as standalone. This is another classic question. What is Azure Service Fabric? So Azure Service Fabric is actually a distributed system platform that makes it easy to pack, deploy, and manage scalable and reliable microservices and containers. Now, Service Fabric also addresses some of the significant challenges in developing and managing cloud-native applications. And the problem that it addresses and fixes is, now developers and administrators can avoid complex infrastructure problems and focus on implementing mission-critical and demanding workloads that can be scaled and that can be managed through the console or from the single place. In short, Service Fabric provides a platform that makes the process of developing microservices and managing application lifecycle a lot easier. And the advantages of Service Fabric is that now we can produce application with faster time to market because all the worry about the infrastructure is taken away from us. We don't have to design an infrastructure. all that we need to worry about is simply the application and the application lifecycle. Again, the advantage is it supports Windows, it supports Linux. Not only that, it supports servers on premises and in the cloud. With Service Fabric, we can scale up our environment to even 1,000 machines in just a single command. Or if there is an immediate need for 1,000 machines, I can immediately scale them up to 1,000 machines. That's possible with Service Fabric. Now let's look at this question. You can expect this question if the customer is running hybrid environment, meaning having some of the applications in on-premises and running some of the applications from the cloud. And for some reason, when classifying the application that goes to the cloud and that stays on-premises, they have decided to keep the database in-house. So in that environment, a lot of customers do that. So in that environment, this is a classic and a scenario-based question. A client wants the front end of their application to be hosted on Azure in the cloud and wants the database to be hosted in on-premises for security reasons or to have full control on their databases. How do we go about suggesting a solution for this customer? The ideal solution in this scenario is to use the VNet-based point-to-site VPN solution. So all the front-end applications will be in the cloud and they'll be hosted in a VNet, and from the VNet they'll be connecting to the database through an point-to-site VPN. So the traffic and the writings and the reads are not coming through the internet, but through a point-to-site VPN link that's connecting the Azure VNet and the on-premises environment. And this model or this approach or this solution is best suited for scenarios where there are only a limited number of resources that needs to be connected between on-premises and the cloud. This is a very common question. What's Azure Traffic Manager? Of course, we no more running applications on a single server. We no more running applications on or from a single environment. Right? The same application is being run from multiple environments within Azure, and it can be running from Azure and on-premise as well. So multiple environments between Azure and on-premises. And a lot of customers have such environment. And if you're facing an interview with such customer, this could be an ideal question. What is Azure Traffic Manager? Now, the Azure Traffic Manager is a DNS-based traffic load balancer that actually enables us to distribute traffic between services across Azure global regions. And by doing this, it provides a good availability and a good responsiveness to the application. And this traffic manager, it uses DNS to direct client requests to the most appropriate service endpoint based on the traffic routing logic and the health of the endpoints that it maintains. So in short, this traffic manager is a load balancer that enables users to provide high availability and responsiveness by distributing traffic in an optimal manner across the Azure when we run the same application in different regions. So some of the advantages or some of the use cases of using Azure Traffic Manager is it provides multiple automatic failover options. It also helps with reduced downtime. It also helps with the distribution of user traffic across multiple locations. So one location is not overloaded. And then it helps with users knowing from where our customers are getting connected from. That's another big use case with Azure Traffic Manager. Let's look at this question. Right, this is an ideal question. Now there are a group of servers connected together within an virtual network, and now we need to move them or create a separation between them. How do you go about achieving it? So the question goes like this. You need to isolate network traffic among VMs in a subnet, which is part of a virtual network with little downtime and impact on the users. So that's the given scenario. And the best way we can do it is create a new virtual network and move all the VMs in that subnet to the new virtual network. Now, this feature is not possible with a lot of other cloud service providers like AWS and a lot of other providers. Now, in those environments, we might need to shut down, we might need to stop the VM, create a new VM based on the image, and it's an hefty process. But here in Azure, I can simply move the VMs from one subnet to another virtual network without needing for any additional security like the network security group. I can simply isolate them if I need to by creating a simple new virtual network and moving the servers to the new virtual network. Look at this one. This is another common question. With respect to Azure, what is public, private, and hybrid cloud? So this is really to test how well have you understood the different cloud offerings in the market, public, private, and hybrid, or at least the three basic offerings in the market: public, private, and hybrid cloud. Now, the public cloud is the most common way of deploying cloud computing applications, and it has resources like servers, storage, and are owned and operated by third-party cloud service providers like Microsoft Azure. Microsoft Azure is a very good example of public cloud. So here, every component that the user is using is running only on Azure. That's public cloud. Right, let me talk to you about some of the advantages of public cloud. Some of the advantages is low cost, because there's no need to purchase hardware or software, and we pay only for the services that we use in public cloud. And there is literally no maintenance, because the service provider maintains the environment for us. And with public cloud, we have nearly unlimited scalability, meaning we can get resources on demand and can meet our business requirements on demand. And the public clouds are very highly reliable, because they have a vast network of servers, and they ensure that our application does not fail. So there are some advantages of public cloud. Let's talk about private cloud. Now, private cloud consists of compute resources used extensively by one business or one organization. Now, this private cloud can be physically located at our organization's on-site data center, or it can be hosted by a third-party service provider. Whichever the case, the private cloud services and infrastructure are always maintained on a private network, and they're maintained on hardware and software that are dedicated solely for one organization or solely for your organization. So in short, private cloud in Azure is Azure services being run within an on-premises data center, or on-premises data center used by the user to host systems or applications. And some of the advantages is it gives more security. Resources are not shared with others, so a higher level of control and security over our resource and application is possible. And then we have hybrid cloud. Now, hybrid cloud is the best of both worlds. So it combines the features of both public and private cloud. And some of the user components are being run on Azure and others within on-premises data center. So they kind of share the resources. In other words, they kind of share the application. Half of the application would be running in on-premises, and half of them would be in the cloud, and they would be working in harmony to support the application and the business need. So that's hybrid cloud. This is another good example question that wants to test how well you pick services, or how well have you understood Azure products and services and are picking the right service for the need. So the question would go like this: what kind of storage is best suited to handle unstructured data? There are a lot of storage options available, and the requirement here is what or which one would you choose for unstructured data? The answer for that question is blob storage, because blob storage is designed to support unstructured data. It works in this way: it places the data into different tiers based on how often they are accessed. Different tier means different performance. Different performance means different cost associated with it. So a lot of add-on advantages will we get when we use blob storage for unstructured data. In addition to it, any type of unstructured data can be stored in blob storage. This is not true with a couple of other storage options that we have in Azure. Only with blob storage we can store any type of unstructured data. And the data integrity is maintained every time an object is changed in the blob storage. And the best part is the blob storage helps increase applications performance and reduces the bandwidth consumption for that application. So they are the benefits that we get for blob storage, and blob storage are the ones that are well suited for unstructured data, and that's what your answer should be. It's really an 5-step process, and if we have done some basic labs with Azure, you can easily answer this question. So it's a 5-step process. First step is to log into the Azure. The second one is to create an resource or a resource manager. And within the resource manager, you would be selecting the resource. And then pick the operating system. Do you want Windows or Linux? And within Windows, what's the flavor you want? Or within Linux, what's the flavor you want? So decide on it. And then entering the relevant information like the name of the instance or the VM that we're going to launch, and the password, the URL that goes with it, and a couple of other relevant information that gets itself attached with the VM, and then select the size of the virtual machine, different size, different types available for the kind of application and for the intensity of the application that will be running on top of it. So select the size of the virtual machine, review everything, whether they're good or not. If there are any changes required, go back and edit them, and then come back and launch, and your VM is there for you to start working within like 3 or 4 minutes, not even 5 minutes. Within 3 or 4 minutes, it gets ready and you can start working on it. So it's a quick and it's a 5-step process, and you should be able to answer it easily if you have done a few labs in Azure. Let's now look at some scenario-based question. You've been posed with a scenario. So we thought through it and we picked some common scenario-based questions that are being asked in an interview, and I thought we'll present it for you with the answers, with explanation, so you can get benefited through it. So let's look at this question. You're asked to make sure your virtual machines are able to communicate securely with each other to ensure security or to have good amount of security. What would you do? And the correct and the best answer for this would be using virtual network in Azure, which enables us to communicate with the internet securely, which enables us to communicate with the on-premises data center in a secure fashion. So the advantage of using virtual network is users can create their own private network, users can pick their own private IP ranges, users can create their own subnet, users can create their own routing between those two subnets. A lot more goes into that virtual network, so it's very customizable, and the users are provided with an isolated and highly secure environment for applications. It's completely isolated from other customers, it's completely isolated from other applications that are running in other virtual network that we own. So within our account, we can have multiple virtual networks, and one application running on a virtual machine is completely isolated from other applications running on other virtual machines. And of course, all traffic stays within the Azure network, Azure Virtual Machine, or within the Azure network, depending on how you set up the routing. If you have set up a routing to go or reach the internet, it's going to go, otherwise it's going to stay within Azure. If you have set up routing to reach on-premises, then it's going to go and reach on-premises, otherwise it's not going to go and reach on-premises, it's going to stay within the Azure. And it also allows users to design their own network, like we already discussed, picking up IPs, picking routing, picking subnets, how many servers should be present in that particular subnet, or how many servers should that subnet accommodate, the size of the subnet, the IP ranges, the NATing, the masking of IPs, creating of VPN, all that's possible with the virtual network. So it really allows users to design their own network, and using virtual machine is how we secure applications in the cloud. Let's look at this other scenario. How do you ensure that every time a user logs in, they are not asked to re-enter the password as part of authentication? So you really don't want your users to re-enter the password every time they log in to a different application. Well, all the applications have their authentication mechanism in place. All of them wants to authenticate the user before they log in. Ensuring the user does not log in every time does not mean that wiping away all the authentication and authorization that's present in that application. You still need that in place, but how do you make the user hassle-free so they're not asked to re-enter the password or the same password again and again? Let's look at the options available. The first one is to enable Microsoft account authentication. Well, it's not going to fix, because with that the user will still need to re-enter the username and password. Deploy express route. It's not going to fix either, because express route is a network level service that connects on-premises to the cloud. So that has got nothing to do with prompting or not prompting for password. And then we have set up VPN between on-premises data center and Azure, set up AD domain controller in VM, and implement integrated Windows authentication. Well, you can use the same username and password for on-premises and the cloud, but this setup, the VPN and the AD controller setup, it's not going to stop you asking for repeated passwords. So this is all about using the same password in on-premises and in the cloud, and this has got nothing to do with not prompting the user to re-enter the password. All right, so that's same password is different from not prompting the user to re-enter the password. They are two different scenarios, so that is also out of the equation. And the last one is configure AD sync to use single sign-on. That's the right one. So when we configure the AD to use single sign-on, then it's not going to ask for the username and password every time we access an application, because we have logged in, and that login is going to stay active for like 24 hours or so, depending on how you configure it. And within that time, you can access a lot of other applications, and it's not going to ask for the username and password because you already have a single signed on and you have signed in using the right credentials. Let's look at this one. You need to ensure that virtual machines remain available while migrating to Azure. What would be the appropriate service to use? Right, let's look at the options. Traffic Manager. Traffic Manager is literally a DNS service. And then let's look at the other one, update domains. It again has to do with Traffic Manager, updating the URL. So the Traffic Manager gets updated and then starts sending requests to that particular URL. It's going to take some downtime because when we update the URL, they will have to be populated to all different places, and it takes time. So within that time, any user trying to access, it's going to fail. And then we have Express Route and Cloud Services. Express Route could be in fact, it's the right answer because Express Route, it's an extension of our on-premises and cloud environment. And in this question, it really comes out from a customer who's having an hybrid environment. So they have applications running in on-premises, they have applications running in the cloud, and they want to have a way to migrate applications from on-premises to the cloud. In other words, kind of do a cutover between on-premises and the cloud. And this Express Route is a service that connects between on-premises and the cloud. So when you do the cutover, the traffic is now sent to the cloud instead of being handled in on-premises. In fact, the services and the application is getting shut down in on-premises. So the request will come in the same pattern. Instead of they being handled in on-premises, they are now routed to the cloud using Express Route, and the API calls get addressed or the queries gets answered in the cloud through the Express Route service. Look at this question. You are an administrator for a website called WebGame, and you are required to validate and deploy changes made to your website by your development team with minimum downtime. So the real question is, how do you validate the deployment changes that's made by the development team? Let's look at the options. Create a new linked resource, create a staging environment for the site, enable remote debugging on the website, and then create a new website. Well, why would you want to create a new website? Just to validate the changes. And doing a remote debugging is not going to help because debugging only captures logs of the changes happening. It does not do anything with validating the changes. Create a staging environment could be or is the right answer, because when we have staging environments, anything that we run on production can be run on staging environment, and any failures that would happen in production, if we simply run it in production, can be captured when we run the application in the staging environment. So that way, staging environment is a very helpful and useful service, and that way I can catch any errors. In other words, I can validate the changes that were done by my development team before I move it to production, and that reduces the downtime in the production environment. Look at this one last question that we have for you. It's a standard tier application is used across the world and uses Azure Website Standard Tier. It uses large amount of image files, so you can get it. This could be an e-commerce website which has a lot of pictures in it, and this is causing the application to load slow. How can we handle this situation? Let's look at the options given. Configure blob storage with custom domain. Well, this application has pictures, but only the pictures is not all that the application has. Right? So configuring blob storage might not help. This could be an very interactive website and that can't be run from blob storage. Let's look at the other options. Configure Azure Website Auto Scaling to increase instances at high loads. Now, it's the picture that's causing issues for the website. It's not the CPU or it's not the memory unavailable memory not enough that's causing the application to be slow. So we need to identify what's causing the application to be slow. So it's not the CPU, it's not the memory. So configure Azure for auto scaling is not going to help. And then what are the other options? Let's see. Configure Azure CDN to cache all responses from the application's web endpoint. A CDN could be the right answer, but look at that. It says a CDN to cache all responses from the application's web endpoint. CDN is not designed for that. Though it can do it, that's not the best way to use CDN to capture all responses from the application's web endpoint. The proper design for CDN would be to cache the frequently used ones. In other words, cache the static content, which are photos, videos, logos, and pictures, and a lot more. Static content that never changes. Let's look at the last option. Configure Azure CDN to cache site images and content stored in Azure Blob Storage. Absolutely correct. So here we will have to redesign the application to store the pictures, high quality, lazy loading or slow loading pictures, because of the high quality and the bigger size. So store them in CDN, and then the content, let it be stored in Azure Blob Storage. That's the right way of designing the application, and if we do it, this application is going to run faster, or the application is going to respond faster to the users.
DevOps has become an essential skill set for today's technology professionals, with many organizations seeking out talented individuals who can help them build and maintain their infrastructure. If you are looking to become a DevOps engineer, this video is for you. In this video, we'll be covering some of the most common interview questions for a DevOps engineer, as well as some tips on how to answer them successfully. We will cover infrastructure as code and CI/CD pipelines, along with many other important topics. You'll often be asked about your experience with ISA tools like Terraform and Ansible, as well as your knowledge of cloud providers like AWS Google Cloud or Microsoft Azure. We will also discuss tools like Jenkins, Travis CI, or Circle CI, as well as concepts of containerization and Kubernetes. There's a lot to learn and a lot to discuss in our DevOps Engineer Interview Questions video. So without further ado, let's get started. But before moving ahead, let's first understand what is DevOps. Now, DevOps is a set of activities and approaches aimed at enhancing the effectiveness and excellence of software development, delivery, and deployment. It brings together the realms of software development, depth, and information technology operations ops. The main goal of DevOps is to encourage seamless collaboration between development and operations team through the entire software development lifecycle. It achieves this through the utilization of automation, continuous integration, delivery, and deployment, thereby accelerating the process and minimizing errors in software development. Now, let's explore who is a DevOps engineer. Now, a DevOps engineer is an expert in developing, deploying, and maintaining software systems using DevOps practices. They work closely with IT operations, developers, and stakeholders to ensure efficient software delivery. The responsibilities include implementing automation, continuous integration, and continuous delivery or deployment practices, as well as resolving issues throughout the development process. DevOps engineers are proficient in various tools and technologies, such as source code management systems, build and deployment tools, virtualization, and container technologies. But how exactly to become a DevOps engineer? Now, depending on the business and the individual function, different criteria for becoming a DevOps engineer may exist. However, some specific fundamental skills and certifications are frequently needed or recommended. First is an excellent technical background. Now, DevOps engineers should be well versed in IT operations, system administration, and software development. Second is experience with DevOps tools and methodologies. Now, DevOps engineers should have experience with various DevOps technologies and processes, including version control systems, build and deployment automation, containerization, cloud computing, and monitoring, and logging tools. Third is scripting and automation skills. Now, DevOps engineers should have strong scripting skills and be proficient in using tools such as Buzz, Python, or PowerShell to automate tasks and processes for this cloud computing experience. Now, DevOps engineers should have experience working with cloud platforms such as Amazon Web Services, Microsoft Azure, or Google Cloud Platform. And in the end, certification. Some organizations may require DevOps engineers to hold relevant certifications such as Certified DevOps Engineer, CDE, or Certified Kubernetes Administrator, CKA, or AWS Certified DevOps Engineer Professional. Well, now, let us begin with some really important DevOps interview questions and answers, as we have already covered the roadmap of how to become a DevOps engineer. So the first question that we are coming up with is, how is DevOps different from Agile methodology? Well, DevOps is a culture that allows the development and operation team to work together. This results in continuous development, testing, integration, deployment, and monitoring of software throughout the life cycle. Whereas Agile is a software development methodology that focuses on iterative, incremental, small, and rapid release of software, along with customer feedback. Basically, IT addresses gaps and conflicts between the customer and developers. DevOps addresses gaps and conflicts between the developers and IT operations. Now, the second question is, which are some of the most popular DevOps tools? Well, some of the most popular DevOps tools include Selenium, Puppet, Chef, Git, Jenkins, Ansible, and Docker, which are considered really important in today's world if you want to become a successful DevOps engineer. The third question is, what is the difference between continuous delivery and continuous deployment? Now, we will address this one by one. So, continuous delivery ensures that you can safely deploy onto production. But continuous deployment ensures that every change that passes through automation testing is deployed to production automatically, instead of manually. Continuous delivery ensures business applications are delivered as they were expected. Now, continuous deployment makes sure that software development and other processes like release are smooth and faster. Continuously, we also make changes to a production life environment through rigorous automated testing. But when it comes to continuous deployment, there is no explicit approval for a developer to require a developed culture. Question 4 is, what is the role of configuration management in DevOps? Now, configuration management enables management of and changes to multiple systems. Also, it standardizes resource configuration, which in turn manage its infrastructure. Also, it helps with the administration and management of multiple servers and maintains the integrity of the entire infrastructure. Next is, what is the role of AWS in DevOps? Well, AWS has the following role in DevOps. First is flexible services. This provides ready-to-use flexible services without the need to install or set up the software. Second is build for scale. You can manage a single instance or scale to thousands using AWS services. Third is automation. AWS lets you automate tasks and processes, giving you more time to innovate. Then comes secure. Using AWS Identity and Access Management, you can set user permissions and policies in your organization. And then comes large partner ecosystem. AWS supports a large ecosystem of partners that integrate with an extended AWS services. Now, if we talk about the sixth question, that is, name 3 important DevOps KPIs. Now, the 3 very important KPIs are as follows. Mean time to failure recovery. This is the average time taken to recover from a failure. Deployment frequency, the frequency in which the deployment occurs. Percentage of failed deployments, the number of times the deployment fails. Now the 7th question is, what are the benefits of using version control? Here are some of the benefits of using version control. Well, all team members are free to work on any file at any time. With the version control system later on, VCS will allow the team to integrate all of the modifications into a single version. The VCS asks to provide a summary of what was changed. Every time we save a new version of the project, we also get to examine exactly what was modified in the content of the file. As a result, we will be able to see who made what changes to the projects. Now, inside the VCS, all the previous variants and versions are properly stored. We will be able to request any version at any moment, and we will be able to retrieve a snapshot of the entire project at our fingertips. A VCS that is distributed, such as Git, lets all the team members retrieve a complete history of the project. This allows developers or other stakeholders to use the local Git repositories of any of the teammates, even if the main server goes down at any point in time. So the next question is, what is the blue-green deployment pattern? Now, this is a method of continuous deployment that is commonly used to reduce downtime. This is where traffic is transformed from one instance to another. In order to include a fresh version of the code, we must replace the code with the new code version. The new version exists in a green environment, and the old version exists in a blue environment. Now, after making changes to the previous version, we need a new instance from the old one to execute a newer version of the instance. So this was the right answer. Next is, what is continuous testing? Continuous testing constitutes running of automated tests as part of the software delivery pipeline to provide instant feedback on the business risk present in the most recent release in order to prevent problems in step, switching in software delivery lifecycle, and to allow development teams to receive immediate feedback. Every build is continually tested in this manner. Now, this results in a significant increase in speed in a developer's productivity, as it eliminates the requirement of rerunning all the tests after each update and project rebuilding. Now, let's move to the next question. That is, what is automation testing? Now, test automation or manual test automation is the process of automating a manual procedure in order to test an application or system. Automation testing entails the use of independent testing tools that allow you to develop test scripts that can be run repeatedly without the need for human interaction. The next question is how to automate testing in DevOps lifecycle. Now, developers are obliged to commit all the source code changes to a shared DevOps repository. Every time a change is made in the code, Jenkins, like continuous integration tools, will grab it from this common repository and deploy it for continuous testing, which is done by tools like Selenium. So why is continuous testing important for DevOps? Any modification to the code may be tested immediately with continuous testing. This prevents concerns like quality issues and release delays that might occur whenever big bang testing is delayed until the end of the cycle. In this way, continuous testing allows for high quality and more frequent releases. So the next question is, how do you push a file from your local system to the GitHub repository using Git? Now, first connect the local repository to your remote repository. Now, git remote, add origin, and then you can see the code. And the second step that you need to do is push your file to the remote repository. Next question is, what is the process for reverting a commit that has already been pushed and made public? Now, there are two ways that you can revert a commit. Remove or fix the bad file in a new commit and push it to the remote repository. Then commit it to the remote repository using this command. And second is create a new commit that undoes all the changes that were made in the bad commit. You can use this command for it. Next is explain the difference between git fetch and git pull. Now, git fetch only downloads new data from a report repository, whereas git pull updates current head branch with the latest changes from the remote server. The second difference is git fetch does not integrate any new data into working files, whereas git pull downloads new data and integrates it with the current working files. Git fetch users can run a git fetch at any time to update the remote tracking branches, whereas git pull tries to merge remote changes with your local ones. Now, coming to the next question. Explain the concept of branching in Git. Suppose you are working on an application and you want to add a new feature to the app. You can create a new branch and build a new feature on that branch. By default, you always work on the master branch, and the circles on the branch represent various comments made on the branch. So after you're done with all the changes, you can merge it with the master branch. Next question is, explain the master-slave architecture of Jenkins. Now, Jenkins master pulls the code from the remote GitHub repository every time there is a code commit. It distributes the workload to all the Jenkins layers, and when requested from the Jenkins master, the slaves carry out build, test, and produce test reports. The next question is, which file is used to define dependency in Maven? Build.xml, pom.xml, dependency.xml, or version.xml. The correct answer is perm.xml. Next question that we are going to cover is explain the two types of pipelines in Jenkins, along with their syntax. Now, Jenkins provides two ways of developing a pipeline code, scripted and declarative. Now, scripted pipeline is based on GroovyScript as their domain-specific language. One or more node blocks do the core work throughout the entire pipeline. Now, the syntax is execute the pipeline or any of its stages on any available agent, define the build stage, perform steps related to building stage, define the test stage, perform steps related to this test stage, define the deploy stage, and perform steps related to the deploy stage. Now, declarative pipeline provides a simple and friendly syntax to define a pipeline. Here, the pipeline block defines the work done throughout the pipeline. So the syntax that follows is first, execute the pipeline or any of its stage on any available agent, define the build stage, perform steps related to building stage, then define the test stage, perform steps related to the test stage, define the deploy stage, and perform steps related to the deploy stage. Again, this was the code for declarative pipeline. And the last question for this video is, explain how you can set up a Jenkins job. To create a Jenkins job, we go to the top page of Jenkins, choose the New Job option, and then select Build a Freestyle Software Project. Now, the elements of this freestyle job are optional triggers for controlling when Jenkins builds, optional steps for gathering data from the build, like collecting Javadoc testing results and/or archiving artifacts, a build script that actually does the work, or the optional source code management system like Subversion or CBS. Well, there you go. These are some of the most common DevOps interview questions that you might come across while attending an interview. As a DevOps engineer, in-depth knowledge of processes, tools, and relevant technologies is essential, and these DevOps interview questions and answers will help you get some knowledge about some of these aspects. In addition, you must also have a holistic understanding of the products, services, and systems in place.
So that's a wrap on our full course on Azure and DevOps. If you found this video helpful, do appreciate it with a thumbs up and share it with your fellow mates. Thank you and keep learning with Simplilearn.